Okay, good morning everyone. First of all, you're very welcome. It's good turnout, and please don't be nervous. This is a great opportunity for you to see some of the other great work that your peers have completed and to learn from that. And welcome everyone to this year's edition of the CAST CAPS. And for those who don't know what CAST CAPS stand for, CAST CAPS is an acronym for the Conference for the Advancement of Science and Technology and the Conference for the Advancement of Professional Studies. And this started in 2013. Before that, we had an arrangement with our partner college in Toyama. So that's Toyama National College of Technology, which is based on the north coast of Japan. So then from that, this is more a hybrid model, which has both CAST and the CAPS, so that's a wider range of vocational areas. So CAST CAPS provides our higher education students with an opportunity, as we've said, to learn from each other. But as you'll hear from our panelists, employers really value not only the vocational skills, but they really value the presentation and communication skills that our graduates can bring to our local employer. So this is a great opportunity for you to learn. So please don't be nervous. This is an opportunity to learn. We had an entrepreneurship conference yesterday, and one of the things that they have said is that every time that you feel it's an opportunity to learn, so that's a good way to look at it. So you will get constructive feedback here this morning from our panelists, who I would now like to introduce. So we have got Heather McKee. Heather McKee is our Director of Strategic Planning, Quality and Support. And I'm delighted to welcome Deirdre Timley, who is a Director from Business in the Community. And I'd like to extend a warm welcome to Deirdre, who has given up her time to come in today to give you and your peers some constructive feedback. So we have got 11 projects, 11 teams today from a wide range of vocational areas. Each of you will have 10 minutes to present, followed by 1 to 2 minutes of feedback from ourselves. So enjoy. First up, we have got Rory, Daniel and Curtis, who are going to present a really exciting project on a smart quadraphonic system. So over to you guys.
So this is our aquaponic system, so it is.
So basically within the platform we'll be going through the different aspects of our aquaponic system. So we'll be going through the design process, how we planned it out, the specification we made, and the various other parts of the system we went through, so the manufacturer, the electronic sides. With this type of system there's a lot of different aspects to it, so the key part of our project was to research everything and make sure we fully understood what was part of this project.
Okay, first thing we should probably talk about is what is aquaponics. If you're not familiar with it, probably the simplest way of putting it is it will be where aquaculture meets horticulture, in that you're using fish life as a basis instead of soil for growing our plants. First stage actually involves the fish waste, and a byproduct of fish waste is ammonia. When it goes up here, it's fed up through this central pipe here, the water, including the waste product, and when it comes into contact with the root of the plant, it's oxidized and converted into nitrite, which is basically a basis for nitrate, which fertilizes the plants. When it's absorbed by the root, obviously any sort of toxic element belonging to the fish waste that first came up is cleared, and it is recirculated into the system as purified water, and the cycle just continues.
So where can aquaponics be used? Aquaponics been used. Basically, we want to introduce a system into the domesticated market. So there's no system as such only in commercial scale. So there is, our idea is to basically introduce something into schools for education purposes, to teach kids about software engineering and various other aspects and stuff about life cycles and stuff like that there.
The idea is that this incorporates all elements of STEM. So if this was implemented in a certain environment like schools, the kids could be taught different aspects of this. So there's electronics in this, and the basis of the electronics with this type of system is that there was software and programming involved. There is also the learning element of using the waste from the fish to create plants, which is another aspect that kids can be taught at an early stage. So it's teaching them about sustainability and how essentially to keep the environment a safe environment, because stuff like this can be used in a wide variety of areas, like urban areas where there's not a lot of sun. So it can be put in warehouses, so that a lot of crops can be grown quite healthily and steadily, and families who may not have the time to go out and get vegetables can quickly grow fruit and veg that can be used and is healthy. So for us to be able to create a big project like this, we needed to be ensure that each process was planned out and the time was allocated for each step. So what we done was created a project plan, which you can see in the documents that was handed out to you. This project plan was just a way of allowing us to focus on each and every aspect of this project and decide what needed the most time or required the most effort, and allow us to be able to make our project in time.
Yeah.
This is our PDS with it, which we use to, from the stakeholders claims with it, in order to design the system. You can see various aspects like the weight. They wanted certain weights and stuff within the actual system itself, and these were known as like wishes and demands. So we built our system around that.
We went through 3 initial concepts when coming to find our final design. This was the first one here, and it wasn't too long before we started finding limitations in it, and that the box coming directly above the tank with little breathing room in between wasn't leaving much in way of a route for plants to get up, and likewise electronics. There wouldn't have been too many places to set them, and obviously when you're running a smart aquaponics system there's going to be a fair amount of wiring involved. So we moved on to this one here that Daniel will talk about.
So concept 2 is just a basic concept where we had the idea of having a top bed which would incorporate plants and a middle bed there which you could pull out and in. So over time, if you had this in a house or something, you could plant in the seeds and push it in, put it in a secure place, and the plants would grow sufficiently from the fish. So the idea was that this could be implemented in a smaller environment where people could just go in, do their job, put it away and come back and see that the plants grew healthily.
Good.
In this concept here, we basically went with the other two and incorporated it into this one system here. So that it's got basically. Let's see.
Well, this is just the closest representation of what we've actually ended up fully designing, and
Yes.
You'll see that in a bit more detail as the slideshow goes on here. But quite early in the design process, something that we decided is sort of something to build our project around was the idea of making it flat pack. The motivation for this was really, if it was to be sold in mass produced units, you wouldn't be putting the fully assembled one in any stock just for all its space intensity. So we actually managed to find a way to condense it down to quite an efficiently sized package. The only thing was, in reality, creating the project took us a fair bit longer than it actually did. So much of it is actually solidly welded, although there is the odd trace of flat pack elements, as you'll see later in some pictures.
Basically, our system works with having two beds at the top here, which will drain off through. Well, this is a wee inlet here, which allows the water that's being pumped up from the bottom tier into these here two beds, and then there'll be siphons in each one of these beds here, which will drain into these side beds, and then that there drains back to the main reservoir through solenoids.
Okay. This is just the first of our engineering drawings here. I think you've got it in the handout there. There's not too much to say about this other than this just gives all the appropriate dimensions as agreed in the design specification for what we were doing. Oh, sorry, that's edited. Down.
So with this type of system, there's a lot of water in it. So this means that over time there's a lot of stress with the weight of the water. So what we did to help us design our final design, we used a software to simulate the stresses that would be involved with this type of system. Now the issue that we had was that this software didn't have the required material properties that we wanted for this. So with the material that we used, it was mild steel. The yield strength for mild steel is around 200 meganewtons. The yield strength for this material that we had to use was 350, but the idea was that it would give us a idea of how the system would work with the water. So from the stress analysis here, the biggest point of any stress is in the corners at 100 meganewtons. So with a 200 meganewtons of yield strength, this is quite good because the factor of safety will be around 2. So for a system that's quite static and wouldn't be moving around a lot, especially for a prototype, this is quite good. So not a lot of stress will be implemented on it. And the displacement here, the various bit of red, there's 0.45 displacement, so there is, of deflection. So this is quite good, especially for a system that is quite static, because over time, if this were to be moved about, more stress may have applied to different areas, so it could cause the frame to break down. But because the frame that we designed, it wouldn't be necessarily moving around a lot, these were quite good results from the simulation that we carried out.
Let's speak about some of the manufacturing process too.
Basically, remember the system was just made from box section and angular, so it was. And the reason why I went for that there was because it was cheap. Obviously, it's going to have the element of rusting, but we have the idea of galvanizing it, so that just to give it a wee bit of a protective layer and then painting it. But you can see here from the bottom tier how the top tier is going to slide in, giving it that sort of element of assembly. So it is. And these basically,
Sorry.
these here are just basically sitting, on the outside here, and that's what's holding it up in place. So it is.
So with this type of project, there's a lot of different components involved. So to give us an idea of how much this would cost, we came up with a cost analysis, just listing the different materials, different components that we would have had to buy throughout time, and displaying which different aspects of this give them as a percentage of cost. So from the pie chart, you can see here that materials is where the most cost comes from. This is because we used a mix of different angle iron, flat bar and box section. So to cut the cost, if this were to be mass produced, it could be bought from suppliers, so it could, which would cut the cost quite significantly. And other components like the electronics or the plumbing, this stuff could also be mass bought from suppliers. So all the costs, if it was to be mass produced, would be brought down quite significantly. But because it was a one-off project, the costs that we had was quite ideal. So we were able to source different components from the college itself and different components from outside the college.
So this is a wee system overview of water circulation, which shows you the siphons in the top beds and also in the upper wee beds here. And basically the issue we had was because bell siphons usually need to be 300 mil, so they do, in depth. But just due to the limitation we had with the boxes, the depth, we had to think of a new way, of creating where there's enough air to get inside. So we just made like a wider diameter, and that's obviously it tapers up here, towards the top. The air's being compressed, so it works well.
This idea, this idea was further developed. Curtis had brought the system back home and he created a prototype through just using a normal bottle and cut it in half, and he was able to fully develop this, which was 3D printed later on to help the water cycle throughout the system and be taken from one medium bed to another, so that the whole water could be brought around the system.
Okay, something fairly unique about our project is the incorporation of an airlift pump system in terms of getting the water from the reservoir or the fish tank to the top bed. Traditionally, you would just use a regular water pump, but there were a few shortcomings of this in that a water pump with its moving parts inside and diaphragms and such like would be primarily designed just for moving water and no solid parts, as this as this project really necessitates. So the idea being that air is just pumped in, and when it is in a compressed area, it has nowhere to go but up, and that will eject the water with it. This original design, it was okay in a lot of ways, but the flow rate, as in the amount of water it was pumping upward every hour, was somewhere in the region of 140 litres an hour, which would not be sufficient for circulating the water through the system enough without the supply stagnating. So I moved on to a second one, which is sort of took on the form of an inverted siphon, and also inside a chamber in the thing, which would put an added element of pressure. As you can see from the bottom here, this is a check valve where the water can come in one way, but it can't come out the other. So when this fills up, as it would when it's submerged, it gets to a point where that will shut off, and there's nowhere to go for the water but upwards as it ejects through this siphon here and outward. This yielded much better results of about 240 litres an hour on top of the 140 of the previous one. So that was a big improvement, and that would be adequate for circulating the water in the system enough to keep it fresh and not stagnate. I have two videos here if it can be clicked at all. Can I click in here? No? Okay.
That's okay.
Alright. So that's the first one there. You can see it's quite stilted in the output. There's nothing really wrong with this in itself, but if you look at how low it is in the water for it to get enough necessary submergence for enough pressure to get the water out, there's absolutely no way that would have gone high enough to supply the top beds. And this is the improved version on the right hand side here, which was submerged in a much shallower base, and it still produced a quite a significant amount more, and also with consistent flow as well, which would be a bit less obnoxious on the ear.
So the idea of this system was that over time different elements could be observed, and with that idea we decided to implement various sensors, which we'll talk about later in the slide. But for the information to be recorded, we needed a certain area specified in our design that would display this. So what we done was we created a control panel where we could use various LED screens where the information could be displayed. So the idea we had was that we could use a touchscreen LED where you could type in information. So especially with the fish, depending on what fish you have, they eat up different amount of food. So over time you could observe this behavior and control the amount of food that's going into the system, so that the waste produced will help make sure that the efficiency of the plants is to the max. So the idea was that the whole system could be observed and information was recorded in this particular touchscreen, and that you could go back in time and find out the point of max efficiency with this particular system.
So this is also the wee fish feeder here, so it is, which is located up just above the fish tank here, which is obviously just feeding the fish. What were you going to say?
Among the sensors that this system uses are a moisture sensor, which, as you can see, would be sitting in the smaller bed containing the grow media, which is likely to be clay pellets or something such, and also pH meter and temperature and humidity meter. The thing about these is that they don't necessarily automate the process in itself, but when connected, can serve as a good early warning system for some sort of malfunction in the system. For instance, if this was generating a low reading, it would most likely indicate that water is not being pumped up and circulated into the system. So it sort of indirectly serves as an alarm system for the pump. And likewise, the pH. The
pH will indicate, so it will. Obviously, the pH within the water, because you want to keep it quite neutral. So you do. If you don't keep it neutral, and it was too acidic or whatever, it could kill the plant and have a bit of a an ongoing effect within the system.
For fish generally, the likes of tilapia, which would be very common in aquaponic systems, they thrive in a pH of around 6.5 to 8.5, which is, in the neutral to slightly alkaline range. And anything above, when you're starting to get into the region of around 10, that would really suggest a build-up of ammonia in the water. And again, that just serves as a suggestion that something's not quite circulating, or the plants aren't quite filtering at the rate you'd expect them to be.
If you want to go back there just a sec. The idea behind this is that with a system like the aquaponics, to be able to grow plants efficiently, you need to have various information so that you can adjust the system compared to different environments. So with the sensors, this will give the user different information about how well their system is going at the minute, so they can observe this, input it into the touchscreen, and over time they can go back and see at what point the plants were going efficiently. And with information from experts on like fish, plants, they can gather information and implement all this into the system, and over time make sure the plants they're growing is efficient. So this is just a brief overview of the circuit design. It's a small circuit. The idea is that the electronic box, which is pointed out in the drawings, it will hold all the electronics in this, keeping it safe from the water. The Arduino here is essentially just the brain of the electronics. This is where all the program is written, and the information will be read from the sensors to the Arduino, and the Arduino will then write it to LED screens. Another concept we had was that we would be able to use a Bluetooth device, so that you could pair your phone up to the system and read live feed from the sensors. The problem with this, and especially the LED screen that we had used, there's not a lot of resources in this, and with the amount of different components within this system, a lot of time can be dedicated to this, but through testing and eventual improvement of the program, we could implement this.
Yeah, thanks for watching. That's our presentation.
Well, thank you.
Thank you.
Very well done. It's very difficult going first. So congratulations.
Thank you.
On that. Very, very detailed presentation. Can I just ask which one of you is which? Who is?
I'm Curtis.
You're Curtis.
Rory.
Daniel.
No, thank you. Very nice to meet you.
Thank you.
One of the things that struck me was at the start you showed a photograph, obviously, of a commercial scale of flow-on plants.
Yeah.
Did you do any cost comparison between what it would cost to do your model versus doing this on a commercial scale? What would be the cost of developing?
Well, it's not 100% comparable, simply because ours is designed as a home system. I mean, the thing about it is it does look quite cumbersome in size, but generally the larger you can get, the more sort of beginner friendly it is, simply because the more water circulating, it would take an awful lot longer for anything to go wrong, to actually go wrong, compared to, let's say if you had like a tabletop size one, you wouldn't be, if there was some sort of deficiency in it, it would propagate quite rapidly. So ours is primarily just geared at the domestic user.
Okay.
A lot of these systems is actually used in the places like Barbados, where there's not a lot of water, where it's being commercialised there. So the cost in comparison to ours is quite significant. They've managed to make it on a bigger scale with our houses and whatnot, because ours is a one-off project. The costs that we incurred was a lot higher than what they would, because of like the components we were searching. With the likes of them, they didn't have a lot of electrical components like we would be able to get. The difference between the two is that theirs is more they can mass buy stuff from certain suppliers and whatnot. So if ours was to be implemented in like a commercialized environment, we took in consideration that all this material and the components could be either made in-house or bought from other suppliers, which would greatly reduce the costs.
Okay. Thank you.
I guess just the question, I mean, obviously you said this is going to be used in domestic setting. You mentioned domestic setting and schools. Have you done any market testing, with those client groups to see potentially, you've obviously factored into the presentation some of the needs in terms of flat pack originally and then how that evolved or whatever, but I was just wondering, have you done any more market testing with those client groups to get a real feel for, the next stage you need to bring it to?
No, not really. No, I've done various aspects, but my son attends Clannivoy Primary School, so he does.
Right.
And they've won some award for like bringing in like a system, so they have outside it's like a pond system
Okay.
of like sustaining like life and stuff like that there. But they also do a lot of healthy eating and stuff in school as well, and that's where we feel that could be introduced in the schools. 'Cause
Links into the curriculum.
yeah, exactly.
Very good. Thank you.
Yeah, that's just what I was going to add. I think it's a really, really good project, and I think the schools is a great environment for it. Obviously, you guys are the experts. You've been working, living and breathing this for the last 8-9 months. I do agree with what Heather was saying. I think if it's for a school environment, I think that the materials that you've constructed it from are ideal. However, for home environment, albeit there are issues with in terms of managing whether the water is too alkaline or too acidic, but I think that the size of it would need to be perhaps reevaluated, and maybe the structure in terms of what you use to make that needs to be to look at, because maybe I'm not sure you look at the idea of using hard plastics maybe for the frame. If you were going to use a smaller version one that would be more suitable to a home.
At the start, we originally looked into using plastic for ours, but the issue was when we contacted suppliers, the price they were giving us, because it was just a one-off, was quite high.
Okay.
So
But if you look at what you've learned, I mean, if the whole idea in us, you coming here, is that we educate you so that you go out to employers that you're work ready. And you've learned about SolidWorks, you've learned about FEA, you've learned about what a PDS is, you've learned about spreadsheets. So this is, and congratulations to each of you and to your coordinator Stephen, because that's a really, really high bar to be setting for the first project. Really, really good. You've learned a lot, and I think there's a lot of collaboration or a lot of possibility here for this to be extended out to other areas, such as whether it's animal management. You chatted about there the Arduino, so it's even open to electronic engineering students. So in terms of project-based learning, this could be extended and rolled out.
And that was our idea as well, because we mentioned in various wee things there about how you could incorporate even into here, so you could, and then even canteens and stuff, like upstairs, could even be growing their own vegetables and stuff. And then animal management, be looking after obviously the pets and stuff, the science.
Yeah, it's a great educational tool. Well done. Thank you.
Thank you.
Thank you.
Good morning, everyone. My name is James Robinson. I'm here with Simon Keys, and we're going to be talking to you about our HND second year project, which was the refurbishment of the previous year's SERC Formula 24 Plus car. You can see there a picture of the car that was entered last year. A bit of background. The car was built by last year's second year HND students, and I was in my first year, obviously last year, and due to my background in amateur motor racing, I was asked by them if I wouldn't mind driving the car, and I had a great time doing that, and we thought we'd want to move forward with developing the car for our project this year. So obviously, because this is going to be entered in the Green Power Racing Series, it has to conform to the technical regulations and standards set out by Green Power. And it's important to note here that this car is not a new build, and as I've mentioned, it is a rework of the existing car. So with this being a group project, we had to indulge in a bit of a project role delegation. So we split the project up between ourselves into two main elements. I would be focusing on the steering, focusing on strengthening the steering setup, as well as employing proper Ackerman steering geometry to ensure a good turning motion and proper handling of the car, whilst Simon would be looking at the drivetrain and be looking at a move away from the belt system which we'd employed last year. The belt system, while it worked, to get it to stay on its sprockets you had to have the belt very tight, which we felt was causing inefficiencies in the drive system. Hence we wanted to look at other potential solutions. Now, an early part of the project, and of any project, is to produce a product design specification, or a PDS, and in our case this is based broadly on the technical and sporting regulations for the 2018 season as published by Green Power, and we've got a handout there showing our PDS if you care to have a look at that. Another part, an integral part of any project before you commit anything to metal, is to produce a project plan. As you can see here, we divided up tasks and resources between the two using Microsoft Project between myself and Simon. Okay, moving now to look at our concept. This was the first concept, and this employed a beam axle similarly as was used in the car last year, but the theory behind this was that we would employ shiftable camber angle, which would allow for fine-tuning of the handling of the car. However, we ultimately decided we weren't going to proceed with this concept, as the degree of adjustability would be too crude, and I felt that it was just a potential area of weakness, as we had experienced issues with the strength of the front axle in the previous season. This is just a development of concept 1, showing how the track rods would interface with the hubs and the steering arms. In concept 2, we looked at moving from the basic sort of track rods and steering arms setup to something employing a rack and pinion, such as you'd see in quite a lot of road cars. However, ultimately we decided not to move forward with this one either, on the basis that this was just adding really unnecessary levels of complexity for what the car is. And we'll see here concept 3, and this is ultimately what we went ahead with. You can see we have detachable bolt-on, bolt-off hub carriers, these C-shaped pieces, which would be set on the beam axle at a 3-degree camber angle, and you can see that we're going ahead with the steering setup broadly similar to what was used last year, using the track rods and this block in the middle to interface with the steering column. And as I've been saying there, we had to go through a concept synthesis process, and as I've explained, we're moving ahead with concept 3. I'll just hand you to Simon now to talk a little bit about his drive system concepts.
Thank you very much. Moving on to the first example of my drivetrain. In the first example, I plan to continue with the pulley belt originally, with the introduction of an idler gear, which would act as a sort of stepper upper for the motor, so that rather from running from a rather low gear ratio to a very high one, it would go through a middle stage, which would allow it to gradually increase and hopefully produce a better result in terms of speed, efficiency and performance. But when it came to production time, we realised that for the construction of such would require the motor to be moved closer to the driver's head, which presented some major issues when it came to the health and safety of the driver. And with the time, and seeing as we were, like as my friend James illustrated, we were working on a refurbishment, so we were limited to the space that we were working in, so we had to make use of the space, and as such there was no room for an idler gear, which brings us on to concept 2 now. Concept 2, I plan to bring in a differential, which would allow for both wheels to run off the same axis and revolve at different speeds. This seemed like a good idea initially at the start, but moving further forward with the idea, we realised that a differential they're very heavy, as you would have to, only really used in larger scale vehicles and would have to be recovered from such a place. They would also require a lot of time because you would have to get the gear ratios right in order for the smaller wheels, because the cart is not built to the size that most differentials would be. And once again, time and space constraints regarding the size, weight and placement of it. Which brings us to our final concept, which is where I plan to use a recovered bike derailleur gear shifter. The purpose of this being a lead on from concept 1. In concept 1, as I mentioned, I plan to have a stepper upper. Concept 3 took this idea of having various levels of gear change. So I brought in a gear sprocket which was recovered from an old bike, our own purchased derailleur, and our own components here, which if you'd like to see, there are drawings available for you to have a look at. And this would allow for the driver using a gear shifter in the main cabin to adjust his gears as needs be to get the speed and torque he needs on the track on the day. And if this is our final synthesis, where if you take the time, you'll also see we decided on the final concept 3, because.
Okay, now we'll look at what's some SolidWorks. Once we decided what steering system we were going ahead with, obviously it was time to start drawing things up. And these are renderings of the front axle setup as now exists in the car. And you can see there the middle section, the beam axle, that was actually recovered from the car as it was run last season, because that had been made to overcome a failure in testing last year, and it functioned flawlessly on the day, so there was no strength issues there. So, you know, if it ain't broke, don't fix it. Then the hubs, the hub carriers, last year had been welded on, but I felt that having welds of possibly unknown quality and strength was just an area of weakness that could fail. So we decided to move to the bolt-on, bolt-off hubs, and that makes the car easier to maintain if there was to be a failure as well. And as you can see from the inclination in the drawings there's a 3-degree camber angle set up, and that's really to allow the steering to self-center itself properly due to the inclination of the kingpin. And as well as that, when the car's going hopefully at speed in a racing environment, you increase the contact patch of the tyre with the road, and that allows for more neutral and balanced handling. Okay, and here we've got a bit of stress analysis that was done in SolidWorks. This is one of the hubs. You can see there's a 3D printed version that was produced before we committed anything to metal, and you can see from the stress analysis that this is mild steel. We've got a yield strength of 200 newtons per meter squared, and see there from the multipliers on the scale, the worst stress really that can occur in this is about 45, and that's using a load of 50 kilograms. We calculated that because the cart weighs about 120 kilograms, and the average male weighs about 80, so we've got a total weight of 200 kilograms split between the 4 corners. You arrive at your 50 there, which is 500 newtons a load, and you can see there from both the obvious colours in the graphic and the numbers there, you're not going to get anywhere near the sort of load that's going to trouble the materials. And while we have a bit of deflection shown on the diagram, that's a worst case scenario, and in reality there's no deflection on the part at all. And as I was saying, we put things through the 3D printer just to see that they would fit in the hub carriers, that the design was okay to go ahead with before we fabricated anything, and that's what's on the table there. Just got a quick video here. I hope this plays okay. This was the part. That was just a part of the drivetrain being produced. I just thought that would be interesting to have a little video. Okay, and Simon will be able to tell you a bit about this slide.
Thank you. As I mentioned earlier, the final concept had the gear shifter in it, using the derailleur. Obviously the derailleur needs to hook up to something in the cabin that the driver can get at, so we recovered the original shifter from the bicycle and mounted it on a simple post, which would allow just regular turning at his own comfort if he needs.
Okay, and that's the final fabricated version of the hubs. That was made, the upright section and the stub axle were made as turned components using a CNC teach turn lathe, and then they were welded together. There was a hole drilled in the stub axle, the upright was placed through it, and that was welded together by myself. and then obviously the steering arm was welded on at 12 degrees, which we calculated to be the correct angle for the steering arms for Ackerman steering geometry to give a true turning motion. And here we've got pictures of the of concept 3 in reality. This is the shiftable gears. You can see there we have the bicycle derailleur, the cassette gears interfacing with the motor. This was tested, as you'll see in a video in a moment. The gear shift works. It worked flawlessly. However, the gear ratios were placing undue strain on the motor. So as a result of our testing, as you'll be able to see from the videos, we've decided, given the time constraints until the race, we're going to go this year with a single speed setup using a lower gear ratio. However, if we were to have infinite time to develop the car further, I think we would look at using lower gear ratios but using the derailleur, and then perhaps instead of the cassette from a bicycle's rear axle, we'd use the chainring setup from the crank of a bicycle, or perhaps machine something bespoke in the college to suit our purposes exactly. It's just pictures. This first video, we tried starting the car off. We brought it outside, didn't realise it was in its highest gear, and if you've ever tried to start your car in 5th gear, you're on a hiding to nothing. And you'll see from the video that this didn't go well. We had to have a little push. So what we did after this was, in the next video, this is gone a bit out of focus, we lifted the car off the ground, ran the motor up, and we were able to change the gear, because if we were on a hill, we weren't going to be able to move it off in 5th gear, so we had to bring it down to 1st gear to continue testing. That's it successfully shifting. We'll cut that off before it just goes to Simon's feet. And this is yours truly testing the car in the car park, and it ran quite well.
But I would like to have some
You'll be able to see there the camber angle on the front wheels. That's what I was talking about, just about improving the handling of the car. I think that's, we need to see that. Okay, so Simon, do you want to talk through this?
Certainly. So, having seen what you have seen in the testing process, we can now come to our evaluation in the final. So, the pros was, the gear shifter did work, despite some reservations from certain people that it wouldn't. The unfortunateness of it was that we used the wrong sprocket. We should have used the front sprocket from the crank handle rather than the one on the rear wheel, because the tooth ratio was very similar to 1:1. Ideally, you want something more in the range of 1:2, 1:3. And unfortunately, this is going to bring us on to our next slide, where we've had to revert to admittedly more improved version of the original system.
Yeah, as I was saying, with the time constraints, while we would love to ideally go towards maybe 2 or 3 shiftable speeds using lower gear ratios to improve the torque of the car, time constraints in that the race is on Saturday, have caused us to come to this sort of compromise, and we've got a chainring there that gives a gear ratio of 1:3, and that's actually going to be tested this afternoon. That's on the car now and in place. We just need to set the chain on it and test her, but we've no real fears that's going to be any problem, because that's not too far removed from what was run in the previous year and what a lot of the other teams in the Green Power competition are running. And while it's not what we had wanted to do with the project and the shiftable gears, I think we have to take a pragmatic approach. We have to get the car out, and we can build upon that in future. Thank you very much for listening to all that, and if you have any questions, please fire away.
Thank you very much. Very, very clear, well set out presentation from beginning to end. One of my questions was, when is the race? You've answered that. What I liked, I suppose, is more of a comment than anything else, a question, is that you identified the problem, and even as you move forward, you very clearly set out all your different concepts and why you went with what you went with, and then in the terms of time, you've had to revert to something else, and I think that's very honest, and as you said, it's very, very pragmatic. So I just want to say well done. I have no other questions on it.
No, I thought it was a really good presentation and very good overview and very confident presentation as well. I guess I'm just keen to know, in terms of the learning, what do you feel were the key challenges, and what would you maybe do differently next time around in terms of maybe an approach to an aspect of the project?
I think, to be perfectly honest, the element we really could improve on is we'd like to have the car tested earlier in the year, so it's possibly a time management thing.
Okay.
You know, if we'd come across these problems a month ago, we might have been able to get a compromise sort of 3-gear shiftable setup in place for the race.
Okay.
But yeah, that's
Very
a
good.
learning experience for us.
Absolutely.
And we'll know what not to do
That's what it's all about.
in future, as well as obviously just developing workshop skills. You know, I've doing a bit of welding. You know, with the frame and you'll see there. That was the original setup that was in the car, or not the original, the one we tested.
Yes.
That obviously had to be welded to the axle. The new ones had to be put together with the axle, things like that. So we've had an opportunity to develop. Myself and Simon have been more from an academic background than some of the other students in the course, so we've had a good opportunity to develop our practical
Hands-on
skills as well.
Skills. Very good. Thank you.
Yeah, well done, Simon and James, and it's a great example of an open-ended project. So obviously this started last year, and this is what we're trying to do. We're trying to create projects that can be developed year on year to have more formidable projects. And so congratulations again to your coordinator, Stephen, and the technical staff, Bennett, Peter, and everybody else who worked on this. Very, very good. In terms of your concept drawings, the SolidWorks drawings that you showed us, the 3D printing. So you've learned so much through this. So if you're going on to further studies again, this will be a great benefit to you. And you answered most of my questions as you went through. I was quite interested to hear about the ratios. I thought maybe that you're going to use something, given the weight 120 kg, that you're going to use maybe a derailleur with perhaps one that's used with one of the e-bikes, the e-mountain bikes, which might be more suited to this. Maybe that's something that you could look at going forward for next year. The only question I had is, again, I was really interested. I thought your final choice for the steering was definitely the best of the 3 options. The C pieces. Did you use bushings in those?
Yes, there's a brass bush that, if you got obviously your hub sits in there, and you've got a brass bush that takes the load. Obviously it's on the top because it's going down, and that's in there. That was reused from last year's setup because the kingpin diameter is the same, so we just reused the brass bushings, and they're doing their job well. They're greased up and everything.
Brilliant.
Works as
Brilliant.
one would hope it might.
Brilliant. Yeah, well, really well done. I mean, that's on par. I think last year this project actually beat a lot of, if not all, the university competitors.
Yeah, we
So
won our category.
you won the category,
Last
so
year.
you beat all of the university competitors. So that's good to see that that's the standard of project that we're producing here in the college. So well done.
Thank you.
Thank you very much.
Got it up.
I'm Andy Woods from Downpatrick HND, and here's my project of a baler roller. Well, the problem I had was, as you can see, this here is a baler for anyone that doesn't know, and at the bottom here, this is the inside of a bale chamber. These here rollers at the very bottom rotate the same direction, and these create the bale. As the grass comes in, it turns like a Swiss roll you have for dessert. Basically, it's in grass and that makes a bale. So the problem is that with my rollers, they wear thin as the grass. A bale is about 600 kilos, so when it's pressing down on it, it always wears them thin. And also debris and stones from in the soil and grass can get trapped between these rollers and dent and basically kink them and cause damage. So with old genuine rollers here, seen here, the problem is that they have no inner shafts. This shaft does not go the whole way through, it only goes in part way, and it's braced inside, so when a stone hits one of these braces, it kinks and basically there's no shaft to support on. So it needs to be created to wear evenly, so the grass doesn't put down on one area, it wears the whole roller evenly. So, wrong rope. So my project brief was to create a roller less expensive, as genuine rollers are about £700 to £1,100. So let stones drop through would be an advantage if I could do this. So do away with the problem at all completely to eliminate the stone and reduces wear along the roller. So here's the PDS, strong enough to carry 600 kilos upwards. So if one roller was to break and the whole bale was to rely on one roller would be enough. Durable, hard wearing, 50 kilos or under. This is because a person can carry about 25 kilos apparently to law now, and 50 or 30 mil shafts, as this is the two standard sizes. 12-inch diameter, so the whole roller needs to be 12-inch diameter, as this is a quarter of the size. This is a scale model and it needs to be round, it needs to be smooth and no sharp edges. As you see here, this is a bale that had a roller that has sharp edge, and the net has caught the bale and a little bit of the bale's missing net. So here's my first concept. My first concept was to create rubber pads around a round drum. This is a simple idea, easy to change. Though there might not be enough contact between the bale and the grass, as it's very tight near the end. As this is compressed to make a real tight bale, it might start to slip. And rubber and grass in very dry conditions, which isn't very often here, but could cause fire potentially. The next one is twisted and swirled bars. This idea was to create steel on the grass to really turn, and it would help to keep the bale moving and there'd be no sticking. It'd be hard to manufacture in a workshop, especially in tech when you haven't that much time as well. My third concept was to make a roller with bars in it, with gaps in between, so that the stones could actually drop through. This is eliminate stone. Self-cleaning, there'd be no debris getting onto them rollers, so it stays clean. Easy inspected for bends, as you can see right round the whole roller by looking down through it, whereas a roller normally with a centre you have to turn it and look right round it. No similar ideas, although stones or debris may get trapped between the bars. If two rollers are rotating beside each other, it may cause problems. The only thing is, with this one here, there's more chance of netting wrapping around the inside of these bars, which I didn't want. So my concept selection here, as you can see, concept 3, I decided to go with this. Research, I found out that some other rollers and farming ideas, not baler rollers, have shafts the whole way through. So I was thinking about putting the shaft right through, so I thought about it. And here's other ideas of, this is from a plastics baler, which rotates chains, and this rotates, and there's no rollers at all, but the whole thing the whole chain aspect just creates a circle, and the grass is in, or the plastics is in behind this, so it creates a Swiss roll effect. The problem with this is that it would be sort of clattly or rattly and noisy. Legislation I found out to be is that guards is a big one, so when you're mechanic or something, put the guard back on and don't run on. Must be used for specific jobs, so a roller that goes into a grass baler shouldn't be used for a baler for plastics, etc. And there's hazards being pulled into the pickup chamber and contacts with rollers, which is what I'm making, so just to be aware of that. Detailed design, it's maybe quite hard to see, but the roller has to be 12 inches, as you see, 45mm shafts and 25mm shafts. And I had a bit of bother here where the grass, since my design isn't a solid roller, the grass could get down through these rollers and get into the bearing, so I had to try and keep grass out of the bearing, as grass and bearings don't go too well. Here's some SolidWorks idea. This is SolidWorks, as you can see, my whole roller made on SolidWorks. Manufacture here is the manufacturing of the roller. I think these are in the wrong order, but yeah, here's the start. This is the bushings for the outside of the roller. As you can see, these aren't for real life, these are for stands, but here's the creation of these, and here's the shaft being cut and the bushings also being made and the shafts being turned out. Here I had a bit of problems as I forgot to lathe the face of the ends of the shaft, so I welded it in and then couldn't lathe it out, so I had to overcome this by using the centering device to level out the shaft so it wouldn't go off balance while using the lathe. This was overcome easily. Here's a bit of testing. As for doing this, I was able to put the roller in the lathe and try it out. So here is the testing of it, and this here enabled me to run the roller at 700 RPM, which normally the baler roller runs at 400 to 3 to 400, so this has enabled me to test it and well over test it. Bill of materials, here you can see the bills of all the materials 4 times the size of this here, as this is only a scale model, and the total comes to about £310. So if I was to sort of retail this at market, I would say I would sell this about 500 to 600, as it would save the person downtime in the long run, as it should be a more hard wearing roller and last better in the future. Future developments. Materials, is there any harder, better wearing materials than just steel, mild steel? Another one is load sensing bearing, so if it gets pressurized or there's too much pressure or something goes wrong, well, I could alert you and stop the whole thing. Auto greasing system, so it greases the bearings as you're working along, and a shutdown cycle. As this roller, well, the paint will only stay on this for maybe a few bales, as these balers are maybe doing 10,000 bales a year. So, and shutdown cycle could be to maybe when you're turning the machine off, spray the whole thing with oil and then hook it off and wash it, or wash it then. Shutdown cycle. And then that's my end of my project.
Andrew, thank you very much. Very good presentation. I could see this could be commercially viable. Just one other question I want to, have you been able to test it with actually baling grass? I know you've tested it on the lathe and so on. I'm just wondering, with it having gaps in it, will it compress your bale tightly enough to compress the air out of it?
Well, I would need to make another one and then or a full scale model and then try it out.
Okay. Well done. Good concept. Well explained.
Yeah, I thought it was an excellent presentation. I guess just from a point of interest, where did the original, I mean, obviously this was your project and this is what you wanted to explore, but why, are you from a farmer background yourself, or how did it come to the table in the first instance?
Well, last September when I was starting, one of them in a baler at home snapped, and then
Right.
bother trying to get one.
It's good to mention that sort of thing in a presentation, just so that you understand, where the origin of the concept came from. But I think you give a really good sequential overview of the different stages of development, so well done.
Thank you.
Yeah, just echo the comments of the panel, and congratulations to you and your tutor, Trudy. Again, very well presented. Have you had an opportunity, if this was scaled up, to compare what weight it would be with comparison to one of the current models that you can buy made out of plastic?
I think we weighed that and then times it before, but I cannot remember.
It's okay. So if you're going forward, then that's something that you would do.
Yeah.
You would take that into consideration.
Consideration, yeah.
Yeah, but no, that's great. Very well done.
Thank you.
Thank you very much.
Thank you.
Hi, I'm from Lisburn Applied Science, and my project today is about the use of oregano or oregano on silage to prevent mould. The mould that grows on the silage that is a huge problem is called Penicillium roqueforti, or commonly known as white mould, and it has been many people have compared it to the mould that's on green or blue cheese, which it is the same strand, but because of the conditions that's in the acidity, the temperature and the surroundings, it doesn't pick up the same toxicity as it is in the silage. So whenever animals eat it, it has an extremely damaging effect to their insides. It can cause spores to get into their lungs and causes breathing problems. It can be transmitted to animals because with the neurotoxins that are produced, and these neurotoxins can cause circling disease, which is whenever there's a problem with the animal's mind or the brain, and it starts tilting its head to the side, and it can fall over. And if the animal actually gets the disease, it has to be put down to stop mass infection. So that's a huge loss to the farmer's income whenever they have to get rid of an animal, and it can be transferred into humans with their products. So eating the meat of a cow or a sheep that's gotten this can cause problems with humans, and especially with mothers that have to breastfeed their children. So it can cause lots of problems with that. Some of the research that we did was that the fungus that grows, we tried to use different herbs on the different types of fungus, and we found that oregano was the best herb to use because of its different properties. It has many antitoxin problems, and many antitoxins, fungal, viral and bacterial producing or preventing properties. So it was the best use for what we were planning to do. I come from a farming background, and we bale maybe 50 bales a year because we have quite a small farm. So having to lose half of it due to the fungus growing is a huge hit to our income, and it's usually just towards our own animals. So we have them in a small barn because our farm is very small. But because of everything being compacted into a barn, there's no airflow to allow the fungus spores to get away. So there's a lot of circulation in the air. So, and this can cause any fungal properties from the bales be transferred onto the skin or into the lungs of the animals. Oregano. I went through a lot of research to make sure that oregano was safe for humans and animal consumption. It's been used in skin products such as creams to get rid of rashes. It's used for burns, fungal infections, sore throats, bug bites, and as of yet there's been no record of side effects being documented from the use of oregano. It's also been used to cure our MRSA, which is the huge superbug that's going around in hospitals at the moment. So there's been a lot of research into the prevention of that, as well as how it could stop the fungus and these other problems. It also has a lot of benefits. It can increase the mineral intake for animals. It can cure diarrhea, which was also a huge problem with younger animals, because whenever they have diarrhea they lose a lot of water, which can lead to sickness. We did a small experiment using silage from my farm. There was quite a bit of it infected, so we took some of it and we took some of the fungus off of the silage and we plated it on malt agar, and we took some uninfected pieces of silage, cut it up and placed it onto the petri dishes with it. Only on 2 of the 6 that we plated we used oregano oil to see how the effects would be against untreated silage and the tester, the one that has no silage on it. And these are the 2, that's the untreated silage and the control. From what you can see here, the silage has been put on top, and underneath the mould has definitely grown on these 2 plates. And then on our treated silage, you can see that there's barely any mould actually present on the dish. These were kept in the same conditions for the same length of time, and as you can see, there is near to no infection on the plates. Our conclusion is that because the fungus seems a lot deeper on the plate that has the untreated silage, then you can see that most of the moisture that might have been left in the silage might have contributed to its growth, meaning that it probably took some moisture from the silage to make it last a lot longer and make it a lot healthier than what it would be if it didn't have any of the minerals. We also tested this on another smaller project, which was small bales, just to see what they would be like, and we found that we can redo the effects or the conditions that would be on a farm because of the size, and we didn't have the area to supply it. So we tried putting it in a incubator with a small amount of water, but we don't think it worked as well. So all of the conditions were the same, but we believe that the fumes from one of the treated silage infected the rest with the oregano, so they were all treated in the end. Future plans for this project is to try and do it on a bigger scale to see what it would be like in the same conditions as a farm, and trying to scale it up to find the concentration that we would need to treat such a big bale. Also, we looked into the compounds inside of oregano to try and find what the properties was that stopped the fungus and bacteria, and we found this cariol, and we want to look into that in the future to see if we can magnify it instead of using the whole product, because it might be cheaper to create a actual product out of it to treat the silage. Big project.
Well done, Stephanie. Very commercial, I think viable idea once you would develop the next steps of it. Can I just ask you, just if you could recap, you talked about when you'd had some of the bales, or you could replicate the conditions on the farm, and you put some in the incubator, but you thought it had infected the others.
Yeah.
Just explain that a little bit more.
We had around 6 bales in the incubator. 2 were treated with the oregano, 2 weren't treated with anything, and there was another one that had holes poked in, but it wasn't treated with anything to see if that would affect it. And we think that the fumes given off by the oregano had circulated the whole incubator and had cured all of them instead of just the single one. So if we had to do it again, we would try and put it into 2 different incubators.
Okay, thank you. Are you going to be able to take that forward yourself? Is that the end of your project now?
I'll be trying to do this in uni, whenever I go on to uni, because we have to do a project anyway, so I thought maybe I should continue this.
I think you should. Yes. Thank you.
I guess coming from a farmer background as well. So during obviously the silage process and the pit being filled up, is the oregano, is that something that has to be sprayed and or applied in layers in the real life scenario ultimately? Do you think that that's something that has to be put in layers as you're obviously filling the pit as such, or is this a surface application, do you think, and that would prevent the mould growth?
Well, we did get a few questions like this whenever we went down south, but we used this mostly for the bales, the big bales of silage, and we thought if you apply it to the outside, because of the heat, it would evaporate down into the centre of it. But if it was applied to a pit, they would have to be applied over the top and then a layer of film over the top of it to let it filter down and through instead of the rain washing it away.
But that's obviously then something that can be tested in the next stages of the concept down the line. Very good, excellent, thank you.
Well done, Stephanie, and to your lecturer, Bennett. Again, another very good project. What did you try and test the temperature of the silage within inside the bale? Because obviously if you're using the incubator, the 2 temperatures, you want them to be something similar.
Yeah, we find it was around body temperature, so around 27 degrees. And we tried to recreate that with the incubator, but we couldn't quite get the temperature right.
Yeah, that's really no. I had a similar question to Heather, so that's very, very interesting outcome, and well done.
Thank you.
Thank you.
Hello, I am Matthew Todd. I'm doing my HND in Applied Biology in Lisburn Tech. And my project's been on the trends of dissolved inorganic nitrogen and macroalgae species in Belfast Lough. The project I've been working on, I did a placement at the NIEA over a couple of weeks. And I was looking at the data they had collected over various years on the species count of macroalgae, also known as seaweed, and dissolved inorganic nitrogen, so that would be the sum of nitrate and phosphorus within Belfast Lough. As you can see there, so the 3 areas that I've been looking at would be the inner Belfast Lough, the outer, and then obviously Belfast Harbour. It's important because if you have too many nutrients, that will cause an excess in the growth of algae and macroalgae, and macroalgae. And if you have too much of the algae itself, it'll kill off a lot of stuff. It'll take up a lot of the oxygen within the water, so that'll lead to the death of native species, and it'll introduce maybe species that can deal with those conditions. So you're looking at the cod and all that would be in the waters, they'd be swimming away and dying off, whereas say like, you know, the nasty stuff like shrimp and all that you don't really want to be growing there, they'll start introducing themselves, and then slowly over time the water will turn green, and eventually cyanobacteria can appear, and it can be toxic to both humans and the fish within the water. Now the methods for collection was the dissolved inorganic nitrogen. It's easily enough collected for the NIA. They've got probes set up around the harbour and inner and outer lock, so they can just go and get the information in and out. Now it's when it comes to the macroalgae collection, which can be a wee bit tricky to collect. The slide's a wee bit short, but it's a lengthy process to get. But the macroalgae growing season would be in the summer months. So that would be some June to August time roughly they're collecting for their macroalgae. And you have to be on the shoreline for roughly 6 in the morning, and a shore survey can take anywhere between 4 and 6 hours with a team of 10 people. And essentially how they collect the macroalgae species count is they're going on with a reduced species list that the WFD, Water Framework Directive, has supplied us for Northern Ireland. And they're just basically sweeping the shore as the tide's in. And they're picking up the seaweed, looking at it and ticking off how much they have counted throughout the shore. So then there's a bunch of calculations that go into actually seeing if that's a good enough growth, or if there's, there's some bad algae there, don't want any of that there. And here's the results. Now, some of the seaweed data that's been collected has been from before the dissolved inorganic, the DIN. And that's because the DIN surveys were introduced by the OSPAR Commission, and they take them, that came in roughly 2012, so after 2010. But as you can see for Belfast Harbour here, the dissolved inorganic nitrogen, it's been quite high in 2014 and 2015. And if we look at 2014 and 15 there's lower amounts of the macroalgae, and it's slowly increased as the DIN decreased. Now, it's kind of speculative because the DIN's collected in winter, but essentially what I believe is the case is either more invasive species have come in and they're taking up more dissolved inorganic nitrogen in the winter. So when that's being collected, there's more species about, so there's abundance of species that will be taking it up. Or there's just more native species that's taken up, because in Belfast Harbour there's 2 large sewage waste treatment plants that just flood in, so that's what's causing the high DIN. But I asked around in the NI when I was there, so that's actually really low for Belfast Harbour at that time. So something must have happened at the sewage treatment plant, or just collection times were different. And then here's for the inner, so like Hazelbank and Rockport. As you can see, the 2014 data there, it's really low compared to Belfast Harbour, and that's because there's not as many ships coming in and out, and there is a treatment plant that effluents into it, but there's way more species in there, so you're up in the 60s and 70s roughly for these areas. So that again helped me come to the decision maybe that, it's the macroalgae in the winter is taking up the dissolved inorganic nitrogen. Now here with the outer, at Ballymaccormack, as you can see, first result there, that was in 2010. It's up into hundreds, so there's 100 unique species that were growing in Ballymaccormack that year, but it slowly went back down, but it's still relatively high. Same with the Irish salt mines, it's been on an increase. So here's 2016, that's 5 micromilliliters. That's really low, but there's also a lot of species growing. So that's why I'm coming to the conclusion that the species in the winter are taking up more of the dissolved inorganic nitrogen. This can be prevented in various ways. A lot of the stuff coming into the waters would be from farmers, and they're using too much phosphorus in their fertilizers. So if there's, as I say, if a regulation was in place for fertilizers to be reduced, it could possibly reduce on the amount of, the nutrients being washed into the water, potentially cutting down on the DIN. Now for macroalgae, it's a wee bit trickier, because you can't really go in and just take it away and be done with it. There's 2 methods I found that people have been using around the world. One is the use of algicides, which kill off the macroalgae and algae, but the potential problem of that is it's putting more nutrients into the water bodies. So some of the nutrients they could be using could be killing fish there. So it's kind of, you're getting rid of one problem, bringing in another problem. Now there was a Danish company, and they've set up this ultrasonic buoyancy aid device. They put it in the water, set it to a frequency, and it just disrupts the growth rate of the algae, but it doesn't affect the fish. So that's kind of like a best case scenario that's coming forward within science. And yeah, that's it. Through the risk of eutrophication and dead zones that come with the dissolved inorganic nutrients, we can kind of go forward and monitor this a bit more closely and potentially look at further ways to reduce the amount of nutrients and algae in our waters. There we go.
Thank you very much, Matthew. Are you going to develop this further, or is it similar?
I think I might go forward, because I actually live quite close to Hazelbank, so if I got like this, wee book to tell me what the species look like, I could probably just go in the morning, nip over to Hazelbank and start counting away. But I plan to go to the environmental sciences, so stuff that leads into that would be helpful in the final year project.
Okay, thank you.
I guess I'm keen to understand, in talking with stakeholders or obviously influencers in the space, do you think, you mentioned potential legislation in terms of farmers and what can be released or whatever. Do you think it's really a legislation piece, or is it an education piece that needs to happen going forward to try and tackle some of these issues?
Yeah, I think it's more of the part of the farmers just kind of need to understand that if they use too much of their fertilizers, it may be helping them, but it's not helping everyone in the long run. It's really polluting our waters in a way.
I think there is an issue in terms of, obviously farmers feel they're overwhelmed by a large degree of the legislation already, but I guess even with changes in Brexit and all going forward, all of that's up for grabs anyway, and there's more going to be customised legislation going forward, so maybe there's an opportunity there.
Even with Brexit, I believe the NIEA are still going to have to comply to the EU legislation, so the Water Framework Directive, they're still going to be under that for their
very good, thank you.
research.
Yeah, well done, Matthew. And again, your lecturer, Bennett. Obviously, there's been, just looking there at your DIN ratios, they have decreased rapidly over the last 4 to 6 years. I wonder, just with the refurbishment of several wastewater treatment plants and around the areas that you have analysed, did you look to see, or are you aware of what species are actually live in the wastewater treatment plants to treat the
No, I
effluent?
didn't look at the species.
Would be interesting just to see how much of an effect those new treatment plants are perhaps having on the DAN ratios. But well done, very, very informative.
Oh, thank you.
Okay, thank you very much. We are representing the Northern Ireland Film and Television School. I am Thorne, Sam, John and Mark.
Hiya.
And what we're going to do is we're going to talk about one of the projects we've been working on, which is called The Clachan. It is a fictional piece, but we have been working on a number of different things, including documentaries and anything down to music videos. It's all very exciting. Oh, sorry, wrong way. So, film production. When we're going into film production, it is, people kind of, when they start off, they look at film production, they look at the end product, they don't actually look at how much goes into it. And there's actually very much, we have to learn everything from the sort of anatomy, physiology of storytelling, things like that. And then we're working through to writing, how do we do these things to industry standards. And I must say that as we go through every part of the process, everything is aimed at industry. All right. There are a lot of us, there's quite a high percentage of mature students, and quite a few of us work in industry as well. Okay, plus the teacher, the tutors and the teaching staff and stuff all come from industry backgrounds. All right, so this is everything I'm talking about today is just aimed purely at the standards they want in industry. Okay, so like I say, even down to understanding, even down to the way you write the story on the page. Okay, all has to be done to the exact standards that people want. Okay, and they are very exacting. They won't just take a Word document, all right? Everything has to be done the way these guys want them. And then this goes right down then through, we follow the pitching process and all the rest of it, and then we head down right the way to the sort of, the actual production, which we'll talk about, and then the post-production, which is where all the kind of techie stuff comes in. So there were 16 of us here on the course, and what we do then is we're in here 2 days a week full time. All right, so and we will then, so what we did is we started looking at the whole process. We were working towards fiction in this case, so it's camera and lighting and script writing for fiction. So then we're taught how to do this, and then we start to work on our own projects. And we were aiming towards this kind of residential, where we went down to the Mourns then to shoot a short, okay? So everything is like time, bang, 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 just the way it would be, say, in industry. And so script writing. So we would start to develop stories. Everybody developed their own story, and then those had to be pitched, okay? Then this went to a kind of committee who looked at them, and then they went with the ones that they wanted to go with. We were really lucky. We had PJ Hart, who's the script supervisor on Derry Girls, and he's been working really tightly with us, again, making sure that everything is just the way they want it. And so then we produced our scripts and things like that, and then we did our pitches, and we did this just the way it was in industry, okay? So it's a case of having your story, having, your log lines, all these kinds of things, and you're selling the story to somebody as if they were a buyer for film and television. And so we went through this. Luckily for myself, they picked one of mine, which is The Clachan, and this is something that we'll be then talking about then as we go through. So, and this was shot then down in the Mourns. All right, so let me see. Oh, film here. Pre-production. So I'm going to pass that on to Sammy. Yeah.
Yep.
Yeah. There you go. It's just the bottom one.
Okay. So once the actors and actresses had been cast, our teams went through a series of script read-throughs and rehearsals. We were then put together in 2 crews, and each student was given a production role. So from director, assistant director to runner, any type of role that would be needed on a production, we were split into each of those roles, and we were then set out to film The Clachan and The Choice. So the crews then travelled to the Mourns, and we did a RACU report and a risk assessment report. And then we put together shooting schedules, storyboards and shot lists. So then we went through a masterclass in the location of sound for drama with Chris Woodcock, who is a sound operator on the Fall and Line of Duty. And then we go on to the Clachan of the production with John.
So the 4 of us made up half the crew that were on the location. Thorne obviously wrote the script and was director. Mark was the assistant director. Samantha was the director of photography, and then I was the first camera operator. We filmed it in a lodge we rented in Kilkeel. There's some photos from the set. We then took the footage into post-production. This involved making footage logs, edit decision lists, and then taking the footage into Premiere Pro, which is an industry standard software, and working on transition, sound design, graphics, and color grading. We then showed the short in Space Theatre across the road from the college, and we showed some excerpts from people's shorts, basically, just to get a gauge from the audience. And we're now going to show the short, hopefully. Right.
Go for it.
Push it again, John.
It's us. Is that right?
Just 3 more. Please come home to me. The cottage is almost ready. Please come home to me, Mother.
Hi, it's O'Hare. Yeah. I spoke to you about Black's cottage. Uh-huh. Yeah, I'm at the crossroads now. Okay, I'll just follow the road ahead and I'll see the sign, okay. Oh yeah, okay, I'll give him a call when I'm there. No problem. Okay, thank you. Bye-bye.
Hi, you must be Francie. Suppose you want to have a look around? Yes, please.
Oh, this is perfect. Has it been empty for long?
Yes, no, it was my mother's cottage.
1717? Is this cottage 300 years old?
No, no! She delivered every child in these mountains and they all betrayed her.
Sorry, is this an anniversary year?
Yes. Very soon. Very soon. Not much time.
Oh, me neither. See, I'm looking for a place to hide away for this novel I'm writing.
So you'd be interested?
Oh, yes, yes, please. The price,
Okay.
location, perfect.
Shall I take the sign down?
Oh, please, yes.
Okay. Come back at sunset for the keys.
No problem. Right, thanks very much.
Yes, Mother. Time is short. I'll soon have another one.
is the wee house for sale?
Is it a house for the two of yous?
Yeah, just the two of us.
You'll want to come back at sunset.
Come back at sunset?
The keys.
Thanks, we will.
Hush now. Hush.
That's John's edit. We all had to do our individual edit. That one in particular was John's. We've just one more slide. Look. Our project was delivered across this fiction in 4 units. You had the camera and lighting, where we learned our hands-on technical ability. Again, we had script writing, which all ideas were fostered and brought along. Then to the actual production, which is the residential, which is, in my mind, is the definition of project-based learning. We're all out there for 2 or 3 days, using our skills, having fun, and enjoying learning, which I think was key to our course. And then we've got our editing, where we sit and we all use our own skills that we've learned, create our own individual edit. John's was my favourite, to be honest. But the thing about our course is it doesn't just incorporate us, it takes in other courses. Like we are HNC Media, but we had the photography unit there, taking behind the scenes stills. We had our HND drama, who were actors who couldn't do without, and it gave them a chance to learn as well as us. And then the level 3 media, they put on a showcase night for us, where we got to sit and enjoy and see our work on the big screen, which we all enjoyed. But other than that, we're quite happy with the way things gone, and we'd like to thank you all for watching the movie and enjoying the presentation. Any questions?
Oh yes.
Would you want to go first this time then?
No. I'm still trembling here after watching that. So.
It was very, very good. Well done, all of you. Excellent film and good, I think, explanation of the process that goes into that. Can I just ask how you came up with the idea and how you identified the location to film it as well?
All right. Oh dear. Okay, the idea was one I picked up very quickly. I knew that the residential would be in the Mourns. My kind of bag is like history and things like that, so I immediately went looking for myths and legends. Heard about a story about a witch, and then this is kind of like an excerpt from a larger production, and so the story really is about a witch who's been wrongfully accused and burnt, and that's her son. And he is trying to get her back out of purgatory, so it's all part of a much bigger project. So I started writing on that, and then I took a section out of it, and then presented it then to be brought forward as a short.
Okay, thank you, well done.
I guess can I just ask in terms of, I guess, the key challenges of this project? I would imagine, with sort of film projects, the resources and the time management and then the team working and collaboration, you're obviously, meeting individuals and using their skill set that maybe you haven't worked with a lot before. So what were the key challenges for you or learnings from the project?
On set, it would have had to be problem solving then and there. Just like in real life industry, we ran into problems we didn't think we were going to, and you just have to think fast and hope everybody pulls together and works together, and it comes together in the end.
Okay, great.
Well, I do a lot of mountain biking down around the Mourns, and I'll be staying well clear of Black's Cottage. I can assure you of that. I'm typically, my background is an engineer, so for me this is completely different, and it's something I'm not used to, so I loved it. To see that it's equally as good as the other projects, it's just completely different, and that's what I like. I really, really like the diversity. John, your edit, I don't know what the other edits were like, but I just thought that was brilliant.
Thank you.
You see, the introduction music was with the violin. Was that a pre-recorded, or was that our own?
Free sound. There's a website called Free Sound that you can use.
Royalty free.
Yeah.
Oh, so just on that point, but we did send other footage across the music students and they have been writing scores for them.
Oh, great.
So
Great.
within the college
Great.
itself, you
Great.
know, like again, that's another feeder out to
Brilliant.
another group.
Yeah,
So
there's a lot of synergy between us and other courses.
yeah, we like to draw in as many skills and help as we can get from as many directions as we can. You know?
Great. No, that was really, and you say that's a great example. Your school is a great example of project-based learning. So well done, guys.
Thank you.
Right, cheers.
Cheers.
Well, I'm Veronica, this is Callie and Emma, and we're like discussing partnership working, which we've been doing on our level 4 H&C. We had the opportunity to create a community event for like the festive season at Christmas time. The event was like a social gathering for like elderly members of like the community, and it was to help build relationships with local businesses and raise the profile of the college.
Yeah, so the whole idea was getting everyone to be sitting down together, you know, young and old, you know, having a cup of tea, having a chat, and just, you know, talking about the college. Like, they were very interested in what we're doing, and we were really interested in just what their experiences have been as well. It was great to get chatting to them. So yeah, that was a wee picture there as well of that.
So we work together not only with our class, which was a full-time course. There's a part-time course in our level 4, and then the level 2 health and social care students, to create an action plan to make sure that everybody was getting involved in not only the planning, but then on the day of the Christmas party, everybody had a role to play, whether it was just to serve food, sit and talk to not only the elderly members of the community, but we also invited sections of the special needs education from the college itself as well. And then we also invited the health and beauty students to come and do hair and nails for everybody who was at this party. And we worked really hard to plan it, like from the start of the year all the way through to the Christmas party.
Some of like the local involvement, we had Blair House Nursing Home that came down with some of their members of their unit, the SERC SEN students, men caps people came down, relatives of students, so students brought like their grannies and stuff like that as well. Yeah. The head of school came down, and the church officials were there as well, because we ran it within a community hall.
I think it was great to see the students from Bangor campus as well. You know, it was good to talk to them, even though they were doing a course completely different to our course. It was good to hear their feedback on, you know, their campus and the facilities, and it just kind of, you know, we were able to chat together about how, you know, our experiences have been during the year, which was good. Yeah.
So before we started even planning the Christmas party itself, we knew we had to fund it all ourselves. So we did a series of fundraisers. So we did a bake sale which raised around £200. Everybody in our class either bought something or actually baked stuff, and then we just sold it all outside the Willows in the Arts campus. And then we also did a festive movie night which raised another £70, and that was just for our classes. We invited the children along, we played a Christmas film and sold popcorn and drinks, and then from that we funded the entire Christmas party from the money we raised from those 2 events alone.
So we had to put together an action plan, so like we were each kind of given like a team from our class, as well as like some of the level 2 students, and we kind of put in here a example of like we were divided up kind of what they could bring to kind of put all this together.
Yeah, so that's just a wee bit there about how we involved the other courses. So there's just an example, like the hair and beauty. So we were just offering simple things like blow dries and painted nails and makeup application. And you know, there's a wee photograph that showed there was kids getting it done at the same time as elderly. So it just kind of showed that it was all mixing everyone together, which was the plan really.
This is a video that we had. It's just to kind of show that what was going on the day.
Yeah, so this is just some wee bits of feedback that we got from the event. We got lots of feedback, including emails and stuff, but we can't obviously show them. And it was just a couple of quotes there we've got from some of the service users that came to the day, just saying how they enjoyed it and that, you know, it was unexpected to be so good, which was great to hear.
So we also worked with a number of local charities, so in the Simon Community Wave and Lighthouse. Wave and Lighthouse actually came to our classroom and gave talks, like, just to show how, especially how nursing and social workers can get involved outside of the NHS and outside of the trusts, which was really good for us. So we decided to give back to them. So we did a food bank and a clothes drive over Christmas, and we created was it 6 or 7 boxes?
Mm-hmm. Yeah.
Full of food that we then gave to the Simon community, as long as bags of clothes, especially winter clothing. And then yesterday actually we've done another fundraiser, and we'll be giving the funds back to Wave and Lighthouse. So we sold Bacon Buddies tea and buns just. and it was like 150 whenever I left at noon yesterday, so it was
Yeah.
probably a lot more than that now, so it was.
So the funds that we've raised help build relationships within our community, and like we've raised over £400 this year just to go towards donations for like the charities that it'll be split between as well. And it's helped us build relationships with the other students and with like local businesses as well. Thank you for this.
Very, very well done. Really good presentation, but it's a very, very commendable project. I mean, because you've done something, I think, different to the other presentations as well, because it's been about the community and giving something back as well. Can I just ask on a personal level how you think it has maybe changed you each as individuals, and how that will maybe contribute to where you go next?
Well, personally, I would be quite involved with like social work. I've applied for university through social work, and it's like helped me understand like more of like the issues that face like older people, like the loneliness, the isolation and stuff like that, and like how things such as like the day we created could like help re-involve them within the community as well.
I'm kind of similar, like with social work, just that's what I've applied for as well. And it's more, people think social work is just working with children and families, but there's a lot more, like mental health, special needs, and that progresses into adulthood, and there is like more vulnerable people than just children. So it's really opened my eyes like how we can give back to them, and that social work just isn't within the trusts, it's within charities as well, and how charities need to get involved in social work in order to provide services that the trusts at the minute just can't afford.
I think for me, just seeing on the day, as the wee video showed, like everyone being together, you know, all the different age groups, you know, our class, you know, family members, service users, children, and everyone getting all together just showed me how important it is that we don't forget about certain members of the community, you know, and that isolating them to keep them as in, oh, people and children isn't, we know we need to mix them all together because it makes everyone appreciate each other more. And I think it was just great to see the feedback as well, and not only from, I know we put up about service users, but there was lots of girls in our class whose children came to the day and thoroughly enjoyed it as well. So it's just about that. I think, you know, it just showed me that it really is about like a joint effort for everyone in the community.
Oh, well done, thank you.
I guess my comment would be I work for business in the community, and we're all about engaging companies in the communities, and so many companies operate, and yes, they employ people within the community, and that's a very valuable contribution in terms of that income going back into those areas and regenerating areas, but a lot of companies operate and don't understand the issues on their doorstep or in communities. So I think it's commendable that you've, you know, tried to breach that gap. I guess my only query would be in terms of, I guess, that dialogue. I mean, obviously you're a group of students, you did this really commendable and laudable project, and it's brilliant what you've achieved. Do you think there's more that the college then, in terms of feedback to your, you know, the college, that they could do more in a sustained way in terms of a plan of action going forward to do something like this on a regularised basis, or obviously encourage students to be more involved in the community and doing something on a more regular basis?
I think if more courses are made aware of what we've done, even if it's like if our course like next year, like I know for a fact Frank and Judith will do the same thing next year because they did it last year, they did it the year before. If the college can even find a way that this is what Frank and Judith's level 4 class is doing, how would you like to get involved? Is there anything you can donate? Like anything you can contribute? Like even that, like even the littlest bit, like getting health and beauty in was like a stepping stone to getting more and more courses involved.
I think it's like, you know, it's not that big of a commitment for the class. You know, it's a great activity for everyone getting involved. You know, we're all working together because, you know, most of our class are new this year. We're all from different parts of Northern Ireland, so it's great that everyone was able to have, you know, one goal together. And I think it would really, you know, within the college, I think if different groups were helping out each other, it would make everyone understand the different courses a bit more.
Yeah.
You know, I would say that there is, sometimes I feel a lack of understanding between what we do and what other parts of the campus do, just because we don't interact an awful lot. And I think if there was a, you know, a college-wide community project, it might, you know, help people understand a wee bit more what everyone's there for.
Very good.
Which would be good.
Excellent. Thank you.
Yeah, well done, Veronica, Kelly and Emma. You speak very clearly. You've communicated your project very well, and the fact that you have been working, bringing in other areas, special needs, health and beauty, doing things like blow dries, you know, that's a great way of working. And obviously Frank's your tutor,
Yep.
So Frank is a great advocate of project-based learning, and Marjorie's here today as well. You're deputy head of school, so you've got a great team there supporting you. So I'm sure you learned a lot from it. Where was it held?
It was St. Patrick's across the street.
Oh,
from us.
across the way, yeah.
Yeah.
And how was it advertised?
We had just sent out an email to different nursing homes as well to make them aware, and then the pupils in our school were sent out an email as well to kind of let them know that it was going on. And then for the movie night, we sent out an email through the whole college. If anyone wanted to bring their children, they could.
Great, but you're great role models for all of the other students, and because you always get more back from what you put into things like this, you know, helping out others. So, yeah, great. Thank you.
Thank you.
Am I ready to go now? Alright, okay, so my name's Adam Hurl, and I'm just here to talk to you today about what I've been doing for my project design and implementation unit on the HND computing. So basically what I'm doing is a SERC and Downpatrick Northern Ireland Fire and Rescue Simulator and a training simulator. So just a bit of an introduction on this. So basically we were discussing different projects with Howard Biggs, who's the course coordinator. So we're discussing a lot of different projects, and this one kept popping up. Was like we might be able to do something with the Northern Ireland Fire Authority. So it got my interest, and then we spoke then to Chris McLaughlin, who is from the Northern Ireland Fire Authority, just to discuss a few ideas basically about what we can sort of do in relation to a simulation as such. It was sort of very casual, you know. We just came in, had a chat, showed him previous projects that had sort of been done, and had just a general discussion of what could be done, what would you like. And whenever we were talking, he didn't really know sort of what he wanted as such. So we gathered all of this all information from the meeting. I turned around and sort of said to him, look, I said, why don't you propose a couple of ideas yourself, and sit down, have a think, write up a document for me exactly what a sort of fire scenario that you would like within the Downpatrick campus. So it's basically going to be simulated in virtual reality. So you put on a headset and it'll be, be simulated in a 3D environment. So it will look exactly like if you're in the building. So then, coming from this, then it sort of was settled at the time anyway when we were talking about it that we'd be doing a simulation of the automotive vehicle sort of section in the Downpatrick campus. But then he came back and changed his mind and said, no, I would like it to be completely different, which I'll be explaining later on as to how that sort of developed into something different. So basically, what are the sort of aims of this project? Well, I'm looking to build confidence with the Northern Ireland Fire Authority, with SERC. So I'm basically looking to, get the ball rolling, get something created for them, show them what students are capable of, and hopefully have this be continuing on as a long term for students who would be willing to take up sort of projects like this one with the Fire Authority or to maintain on to it. I want to challenge myself. I've never really done anything with 3D environments before. Say the closest would probably be SolidWorks, which is you can just create 3D objects. But I've never really sort of done anything sort of 3D with programming or anything like that. So I just want a big challenge. 3D modeling experience, that's also a big aim too as well. Object-oriented programming experience. So object-oriented programming is a style of programming, and I'd like to get more experience in that, obviously. And also too as well, end-user satisfaction. So I want the end-users of this, which would be firefighters, that are looking to train. I want them to be satisfied with sort of what's being built. So what are the objectives? Well, they are people of various learning styles. I know that they have a booklet, a memoriam, where they go by, which is sort of the rules sort of that they have to follow in fire scenario situations. If you're a visual learner, that might be hard to sort of go by. So getting a 3D simulation would be really, really great in that sense. It would really help a visual learner. I want to build stronger relations with the Fire Authority of Northern Ireland, with SERC. I want this to sort of be a long term thing for students, especially too as well, because like Harbegs is sort of like it's really worked on this for some time, and I think this is sort of the first time this has sort of been discussed with the Fire Authority as something like this happening. It's great potential. I want to make this also too as well enjoyable for the fire officers who are training in this. Give you a quick example. When we were having a quick discussion with Chris, he was all, I would love to just have it and have a cow just randomly appear just within the simulation. Little does he know I have a cow there ready for him if he ever wants it. So what methodology am I going to be following? Well, it's called the fountain model. It follows the waterfall model, the traditional waterfall model, except you can go back to any stage you want. So if there needs to be a change within the analysis, the requirements, the design, the coding, the testing or integration, you can float back to them, if need be, because I find that to be more realistic, and it also offers then potential then for it to be maintained and then to be added on to when evolutionized. So what are the deliverables? Well, there'll be a project specification, of course, in relation to this. I'll be using a program called, I have been using a program called Unity 2017. It's an engine that allows you to program in 3D environments. It's very, 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 very good. And with that, you get assets. Now, what an asset is something that can be added to Unity. So it could be 3D objects. It could be a program that can be used in Unity. Things to help you build what you're doing. So Pro Builder's one, and that basically allows you to create and manipulate objects, and it's very, 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 very good. And with that, Pro Grids And ProGrids is basically, it works with ProBuilder and it allows you to build more accurately to scale. And then Blender too as well. That's an open source software, allows you to 3D manipulate objects. It also is very good too as well, which I'll come to now, is when FBX models, that's a file type of a 3D object, and that's the file type that Unity uses. So if you were to be able to, say, find a royalty-free model online that's in a different file type, it could be easily be converted and brought onto Unity as an FBX model. And if it's royalty-free too as well, that's a win-win, because you can edit that and use it for your program. And then also there'll be the project plan too as well. So basically how this is going to happen, how am I going to, like, what am I going to be doing this week? Am I going to be building on? And then QA results sent to as well. That's a big thing. So if I'm testing and something's not right, I need to get in the ball and get that sorted. So the research outcomes and findings. Well, as I was saying, adding on to what this fire scenario is, it was decided at the level 4 Downpatrick campus. So basically what Chris is sort of looking for is they're looking to enter through here at the Downpatrick campus. Then they'll make their way up to the 4th floor, and then they'll make their way to the fire the fire scenario in the fitness suite in the level 4. So there's been a confirmed fire there, and basically what's going to happen in that scenario is there's going to be like multiple choice questions. So they're going to say when they arrive to the 4th floor, it wants the door to be closed, and there's going to be a multiple choice option, hopefully in the future, where the firefighters ask, right, what's your next steps here? How are you going to proceed with this? And if they were to answer the wrong question, Chris will go to the firefighter, okay, why don't you go look at your memoriam book, have a look to see what you should be doing, come back to it and answer correctly before being able to proceed on. Because in a real life scenario, if a firefighter was to make a mistake, it could have devastating consequences. So he was describing too as well a lot of different things. So what he would sort of like, what in a real life scenario, what's that going to be like? And he put these descriptions. So smoke layers and tongues of flames. He sort of wants a fire with heat waves coming off it, maybe like a desk or something on fire, and like the level 4 fitness suite, something along those lines. And he mentioned too as well that he mentioned this in the email, charge branched, and I inquired about that further because I had no idea what a charge branch was. I was like, what, could you elaborate more on that, please? So basically a charge branch is the hose. It's the hose that they go on with, and that's how they go on as a team of 2, which I didn't know. I didn't know that. And they go on as a team of 2, so whenever they would be opening the door to disperse the smoke, they'd be crouching down like this and putting the hose up into the ceiling to just get rid of that smoke layer. So other things too as well is the breathing apparatus and the dispersing smoke that I discussed about, and obviously I was talking to you about the multiple choice questions that'll be and that within the future. So I have samples of the solution now too as well, which I've been currently building on. Now there's our test. I actually visited Downpatrick campus yesterday for the first time, but there's a couple of issues with the Data Protection Act and taking photos and things like that, which I need to speak to the compliance manager of Graham FM, I believe, about that. So whenever I can, I'll be taking more photos to get the colour schemes right. So these are just wee quick samples of what I've been building. This is a 3D environment. They'll be able to. You're able now at the moment to be able to walk along this. This is the 4th floor. So there's the lifts, there's the toilets, and the double doors, and down here eventually. Basically, what you can do is you can extend the item downwards. So that'll be big for the void that's there down to the reception. They're just double doors that would lead into what I believe the library on the other side. And then that's just the hallway, the hallway of the 4th floor. So when you're looking down at there, be I think this one of these is a hygiene room, disabled toilet. In here would be where the fitness suite is, and double doors. And then that's another door that would sort of lead on into the fitness suite as well. Now, obviously, from what you've seen from the picture, the fitness suite, I didn't really know what the colour schemes and things like that, how the fitness suite is. So take sort of these designs with a pinch of salt, but this room is to scale of the fitness suite, and I actually went down here yesterday, and it was, being able to know where to go when I've never been there before. I'm doing these off 2D plans, which I'll show you in the next image of how I've been drawing this up and extruding it up. So that is to scale, so it's very easily changed. I can change that floor in about 5 minutes now whenever I get the chance to, of a wooden floor, which is what it's meant to be. And then that's just the double doors then leading to one of the back stairways, which I'll be building to as well, just in case if they want the option of which stairs do we take. And then this is the plan I've been building off. The full 4th floor hasn't been built because it's been cut off here, and that's where sort of the library would be and the reception. It does take time, but I've been working very hard on this for about, I would say, 6 days now, and I think I've completed quite a lot in the 6 days where I've been building onto this. It's great potential. It's something that's probably never been done before with the firefighter. They've probably never thought of using virtual reality, to train firefighters. So thanks for listening. Do you have any questions?
Well done, Adam. A very interesting project. And well presented in terms of showing the floor plans and how you're building that up. I know you seem to have a way to go yet to get it completed. I'm just wondering, is this your first time working with, as it were, a real life client? And how have you found that process? I know you've already outlined some of the discussion, they've changed their minds and so on, but have you found that beneficial, and what are the main challenges?
Okay, so to address your first point, it's not the first client I've ever worked for. From when I was 14 years old, I was a QA tester for a games company.
Okay.
I've worked with a software election company as well called Modern Democracy, and I worked on a project with them for about 6 months. So it's not in fact the first client I've worked for, but I love getting to meet different sort of clients, and because you sort of see different interests and things like that with IT, you sort of have to take on board another person's interest when it's with IT. So whether it's developing an app, whether it's developing a 3D simulation, I like sort of getting to know different clients and their needs and things like that, because it just makes it interesting.
I guess what occurs to me is, have you thought about the next step of user development or a different client group? I was thinking, I haven't done online learning simulations myself, even very recently for the new GDPR regulations or whatever. There's an element where you did the online testing, question and answer scenario, and then you were told if you got it right and here was why you got it right or whatever. But in this scenario, I could see that as a new member of staff being inducted, that this would be part of the learning that you'd have to go through in terms of fire awareness or health and safety or whatever. So have you thought about that aspect of different user groups, or are you just obviously focused on the fire service in the first instance, get that right, and then see what the other applications are down the line?
Well, it's some of the simulation, of course, so there's endless possibilities of what that can be used for. Put it, for example, say if you wanted to release that, so we'll just give a scenario. If you wanted to release that, say maybe to students who didn't maybe know their way around, new students who didn't know their way around the college, or if you wanted to help them to learn where to evacuate if there's a fire, that could be absolutely altered and changed. If you have the layout of the building, there's other things you can do with it rather than just the fire authority. There's a lot of potential there.
Yeah, I think that's excellent, and it's good to be aware of the other potential move forwards or applications of the software down the line. So well done.
Thank you.
Yeah, thank you very much, Adam. So it's great that you're using industry standard products like Unity, Unity Code, Blender. I mean, that's obviously going to stand you in good stead whenever you go to work in industry. So the majority of the work here would have been involved in you learning Unity and learning that programming language. So again, you may want to develop this if you're going on to further studies, but if you were giving another presentation, because there's so much work went into developing that code, it just would it may help to give the audience a wee bit more flavour of the work that you've put into this, if you even show them a section of that. Because although I'm not a programming expert, it just would give me make it more tangible, because there's obviously a lot of work goes on behind the scenes. But well done.
Thank you very much.
Thanks very much for coming along.
Good morning, ladies and gentlemen. I'm Charles Chadwick, and I'm here with my group member Taylor Johnson, and we're here to talk about our project for the IFA virtual tour, which they have asked us to build for them. So they have the virtual tour. The aim of this tour is that we can build the Education and Heritage Centre within Windsor Park. This is so that people can actually have a virtual, and it'll be built in 3D, so people can actually see what the tour kind of looks like from your side, but so they can attract to get there to it. We intend that the tour will be to encourage to get tourists and also your local people from Belfast and Northern Ireland or Southern Ireland to come to Windsor Park to visit and see what they can actually do. The objective of this is obviously to meet the deadline, because we have a deadline which is for the end of term, so this is going to be quite hard for us to meet, but during our thing we are going to meet this deadline to get it for the client. We're going to need to complete the client's needs, so we need to keep getting the information back and forth, and we are actually got a appointment maybe on Friday and next week to actually go back down to Windsor Park to actually get more information to gather and images, so we can actually get it into the virtual tour. And also we will get the virtual tour on a web server, so we can give our client access to it, so he can keep looking and we can keep updating, so we can get information back and forth, so we can actually see what he wants and imply it, so we can get to what they need. Deliverables for our project, we'll be using Unity 2017, which is good because then we can use the likes of ProBuilder to actually get the walls and everything all together and build the virtual tour as realistic as we can to try and get it. We will be using royalty-free models, so likes of trophies and cabinets and things like that. We can bring them in as an asset into Unity to bring it in as a 3D image, so people can actually see it within that way. We'll also be using a project plan, so we've been doing it on a weekly basis. We can keep up to date and see what task needs to be complete one day to the next, and so we can keep it up to date and everything to try and get to meet the deadlines for this client that we are needed.
To start off the communication, Hard Bags was able to get us in contact with the IFA, and my details were forwarded on to Stephen Garrett, who then me, Charles and 3 other members of the group went down and met with Stephen Garrett. It was just a rough tour to kind of give us an idea of the size of the virtual tour, and I had asked him to send us floor plans so that we could get on with the build. To do the floor plans we're using ProBuilder, and we're then taking a 2D image and making it into a 3D by raising the walls and making it into a virtual reality tour. This was the start of it, as we just started. This was only on day 1 where we're just kind of getting the feel for Unity more, and this was only the beginning of starting to kind of build the shape of the floor plans. This is kind of the progress of it. Still not fully completed, but it was just beginning to bring in the 3D objects and starting to manipulate the floor plans.
So as you can see, this is actually the actual floor plan, and it is now into a 3D image. So, and we've also added in a camera, which is a character camera, which you'll see shortly. So you can actually see how the images and everything, and how that actual floor plan would actually look, in 3D for the real life. And as you can see, this is actually one of the rooms which we have managed to complete so far. Obviously it's not still, but we've managed to complete it. This is actually a room where you can actually go in and take a penalty shootout against the goalkeeper of Northern Ireland. So what we'll be doing in this room is we'll actually bring in an image which will then go on the other side of that wall, and we'll bring in a 3D sphere in there, so that you can actually get your, you can actually go in and so you can actually pretend that you're actually going to kick a football, and actually then goes against the goalkeeper, so you'll be able to see if you could score and things in that against the goalkeeper in Northern Ireland, so you can. And this is actually a real image which is actually be used, and that is actually for the room, as you could so you can actually go up against the players who are and the goalkeeper.
The simulator that's in this room was actually created by students at Queen's University. So obviously the establishment with the IFA has been made between them two, which is why I think it's a good opportunity for us to actually build a virtual tour and for the client and allow people to actually be able to see what's involved in it.
So this is actually another part of the simulation, and this is actually in the game view. So this is actually in the room on the right is actually it's a pentagon shape, which we had to create singly. And what it has is there are obviously objects and things that need to be added in from Windsor Park, which we will collect when we go down there and see, so we can actually see what's to go in the room. And this is actually another room like the penalty shootout room, which is a simulation, and I can't exactly remember what actually happens in the room, but it's like the penalty shootout, but it's something else. And there is actually a colour scheme which goes around as well. When we were around there, it was mostly green, white, because of the green and white army. So when we are near completion and the colour schemes will come in together, the light and everything on it will then bring it up so it looks like the actual real life tour when you actually got your 3D helmet and things on it. So
this was just an example of the types of 3D objects that you can actually download royalties free from websites. When you first, we actually haven't got to it yet, but whenever you first walk into the tour, there's a trophy cabinet and the trophies inside. So what we plan to do is take this 3D object and manipulate it to suit what the trophy is and to resemble the trophy that's actually in the tour. These are just a few concept photos of what the place actually looks like. Obviously on the left you have your logo, and on the right it's the doors where you first go in, and that's where your tour will begin.
And these are just obviously a few images that we will gather, and they will actually end up in the actual project itself. But obviously our client doesn't want too much information given away to obviously bring the tourists and people into it. So some of these images when you're in the tour might be either blurred or they might not actually be there. So it actually gives your client and also you as the audience to actually physically go, what is there? So you can go to come and actually see things there. So you can. And these are just a few more images, such as like the shirt and things. That'll be put into the builder and things like that, and that can come out as a 3D image or a 2D image to represent what is actually there in real life. So we can. And these are obviously just a few more.
This is actually an example of the Pentagon room that we mentioned earlier on. It's just more or less history of past football players and stuff, and again some information may be included. It might pop up as text as you're going through the tour, but we just need to speak further with the client to see what information it is he's looking in and what information he doesn't want in.
And these are obviously the images and things which will be added in as objects and things so they can actually represent them, or things like that. And such as the TVs and things, we can bring them in and just have what's on them screens so people can come and see what they are and things like that. And this is actually the first wall as you walk through it, and then around the corner is the plans and things. And obviously the things such as this box here with how the stadium was actually built itself at Windsor Park, they'll be brought in as images in 3Ds to represent them and things.
This here is just other parts of the building, which unfortunately we won't be doing just due to our time scale and stuff. But our aim is to provide a very good virtual tour where we've actually discussed with Stephen Garrett that if the work is good enough, he would be willing to let the college work on with him. And it means that students maybe next year could either improve on our virtual tour or perhaps start building a tour for other ones. And this would maybe attract actual businesses, to say, like, this is what we have to offer, come and see it. The photo on the left is just of the viewing lounge where you can actually go to watch the football match, and again, this is the type of stuff that maybe students could maybe develop in the next coming years if contact is in place.
Because we want this to be an ongoing project with the IFA, so that, you know, they can have a nice relationship between SERC and themselves, so you can actually bring it together and build, you know, and just so you can have a good relationship, you know, so you can just carry on, you know. And these are just...
That's the boardroom as well. And thanks for listening. If you just have any questions.
Thank you.
Thank you.
Very well done. Very, very good presentation. Well delivered. My question's in around actually the team working. I mean, unlike Adam, who was doing his on his own, you have a large team. Well, not a large team, but you have a number of other people there.
Yeah.
How have you found that in terms of determining who's doing what? Who has been a team leader? How has that worked for you?
I've kind of stepped in as the team leader because I'm the main contact between me and Stephen. It's me and Stephen contacting with each other. It has been tricky in certain areas where getting the team together and discussing it all as one. So at the moment for the build, we've all just kind of been working together. We're all still trying to get used to Unity as well. We're all new. I have never worked with Unity, so we're all stepping in for the build. But because the floor plans are done now, now we will start to separate ourselves, and maybe one person will be collecting objects, others will be focusing on colour schemes, the lighting in the place, because lighting changes as you actually go through the tour, and then we'll all bring the project in as one. So we'll all be working separately, and then at the end we'll have one big project.
Okay, so you're project managing it,
Yeah.
essentially.
Yeah.
Okay, well done. Thank you.
Can I ask, did you do research in terms of looking at other sort of semi-promotional virtual tours that were out there before you tackled this project? And I also want to ask you about the use of, obviously, the Unity. As you say, it's new to you, but do you think this will help you in terms of learning other computerized modelling platforms down the line? Or, you know, do you think now, having had this learning experience, that'll be a help to you?
Yeah, I mean, at the start, before we actually started the project itself, we did a little bit of research, and we were able to go around on the likes of Google Maps and things, and you could actually, with the little person, because you know how you can get the street view of roads and things, well, some of the football stadiums would actually allow you to actually drag him into the stadium, and you can actually have a look round the stadiums. I mean, like the likes of the Nou Camp in Barcelona and Real Madrid and other places around Europe, you know, like Bayern Munich, they actually allow you to actually drag your character into there, so you can actually see what they like. But obviously you can only go to a certain stages, but they can actually you can actually see the stadium inside and things like that. So it has... And
good. And in terms of the language, in terms of learning future, you know, modelling platforms or whatever, how do you feel about that now? Do you think it'll be an easier task next time around?
Well, I think probably it might be, because obviously this is the first which we're obviously trying to tackle, and you know, you never know, you could probably go around other places in Europe and things like that, or you can actually go to them saying, look, I built this wee little virtual tour for the IFA, if you want to have a look at it, you know, I'd be interested in, say, the Scotland Football Association or Wales or England, or, you know, even Europe. You know, you can go to the likes of Spain, France, Germany and Italy and places like that. You know, you can just go around to them and say, you know, because this can turn into a really
good commercial project.
Yeah, because obviously, you know, you're trying to get the clients and things like that. You know, you can go look, you know, here's a start or part of one that we have created when we were back in, you know, and this is perhaps what we could actually go on to do for you yourselves and try and bring them, their tourists and people into their stadiums to physically, you know, come in and basically get more money, really, you know.
That's why I think it's a good opportunity to work with, you know, outside companies as well, especially with me being first time ever creating anything like this. I think it kind of gives me opportunity to prove myself and prove what I am capable of. You know, although we're working as a team, everyone is going to have a full understanding of Unity by the end of the project. So that's why I think that's why I was interested, because I was always interested in getting involved, because this is my first, like, you know, interaction with any outside employer regarding IT. So I just thought it was something really good for me to get into.
Very good.
And what are Stephen's expectations then in terms of having some of the virtual tour footage? Is he expecting that by the end of this academic year?
Yeah.
So do you feel if you had practiced Unity last year, would that have enabled you to be further on in the process or not?
It's kind of hard to say, but I do think it would have helped because obviously the amount of time we have kind of spent figuring stuff out within Unity could have been spent actually getting the build done. So in a way, yeah, I think it would be beneficial, but I am confident that we will have a finished product by the end of it, and I'm hoping that it turns out really well.
And there's 1, 2, 5 of you in the team?
Yeah.
So at the start of the project, did you all have individual roles and responsibilities? And did everybody in the team all stick to that throughout the project?
We all agreed to go down and meet, and whenever we went down to meet, we were all just speaking, we were all listening, and then whenever we got back to the college, we all sat down and we just all worked on Unity. So as of yet, we haven't exactly established as of yet what we're doing, but we all know that because the floor plans have been built now, we all have roles, as I mentioned earlier. The 3D objects will be collected, the colour schemes and the lighting, but before the floor plans were built, there was no real establishment of who was doing what in the team. We just wanted to see what it entailed first before giving any instructions as what we needed to do.
Well, thanks very much. You came from
Thank
Lisburn
you.
today?
Yeah.
Yeah, so thanks to you and thanks to Adam as well for coming.
Thanks very much.
Thank you very much.
Okay, whenever you're ready.
Well, hello, I'm Gareth Lehman, and I work for Linamore Montupet, Light Metal Castings. I've worked here now for 4 years. I served my apprenticeship as a mechatronic maintenance technician. The plant here in the UK makes cylinder heads for car manufacturers such as Ford, Citroën and Peugeot. As part of my higher level apprenticeship, I'm completing the foundation degree in mechatronic engineering. The final module in this was the work-based learning project. Naturally, with me working in industry, I did it in my own plant. My project was to reduce the scrap in the pamphlet cylinder head due to broken oil legs. Broken oil legs are part of a sand core. As you can see in front of you, this is a sand core. The sand's held together by a specific resin. This forms a shape for the internal of the cylinder head. This is a graph. Along the x-axis along the bottom you'll see many references. These references indicate scrap that's been caused by a certain part of the core. F12 and N12 are by far the worst. These are the two oil legs. In this picture you can see, depicted by the two red arrows, this is physically the oil legs on the top core, part of the core pack. This is the cast head. After the core is set into a die, molten aluminium is then poured into it to form the overall shape of the cylinder head. Within the two yellow circles here, you'll see a somewhat distorted triangle. This is not meant to be full. This is meant to be a cavity that is formed by the oil legs that keep breaking off. The first process that I had to tackle was to be a part of a problem-solving Kaizen. I really enjoyed this because as part of the business improvement technique module within the course, we learned the methodology and the theory behind problem-solving techniques. I was then able to implement the Ishikawa diagram and the 5 whys techniques in order to get to the cause of this. When doing a problem solving, within my experience, it's far more efficient to know in detail the process. So you can see in the left hand picture, within the two circles are the different parts of the core. The yellow arrow is pointing to the core conveyor. In the right hand picture, this is where the two parts, as you can see on the left, come together automatically to form the core pack. The core will then move down the core conveyor until it reaches a certain position. A core loader will come across, lift the core pack out of the pallet and drop it into a broken core detection. It is here that the core is checked finally before setting into the die where the aluminium will be poured into. By doing this, we were able to see the possible areas of breakage. Now, there was a lot. The cores are made at a certain part of the factory and then brought round to the loading area, which you saw in the previous pictures. It could be broken transportation. It could be operator error when loading both sets of the cores onto the core loader itself, and it could also be the transportation in the core conveyor. During the problem solving, we came up with two possible solutions. The first one was have the operator who is loading the cores on manually check and then mark that the oil legs are there. This is a good idea because the operator will have to verify and accept that the core is okay. But if it's getting broke further down the process on the core conveyor, it's going to do nothing to get rid of this problem. So the second solution, and the one that we picked, was add another broken core detection sensor to the table. The picture to the left is a broken core detection table. You'll see many sensors that look very similar but come in different sizes. These are, as you look at the picture to the right, the Bluetooth BGL sensor family. This is known as a fork-free beam sensor. Where you can see at the top of the sensor, it is split. This is connected by a laser beam. Whenever it is broken by a part, or in this case, part of the core, it will then be read as present. So we do this for certain parts of the core, which are prone to breakage. Whenever they are checked, finally just before entering the die, if any of them are missing, the core will get rejected. We can then recycle the sand so there's no wastage. It's very important that we catch it at this stage because the moment it enters the die, aluminium will get poured into it. And every scrap head costs us £19.98, and it doesn't take long for that to start adding up to cause a problem. So I knew the sensor that was recommended for me to use. It's just easier for fault finding to use the same type of sensor. We're very familiar with it. We'll keep it in the factory and the stores. And I knew the plan. As a maintenance technician, it was then my job to follow this on through. So there's a few initial checks that I had to do. The first one was make sure the input card, which the signal will go back from the sensors to, had 2 free inputs for the 2 additional sensors. Now, I looked at the electrical schematic from getting the ID of the cable on one of the current sensors on the table, and there was 2 free inputs, but in a factory it's always best to check physically that there is. As you can see, the top left of the right hand picture, that is the input card, and that's where the 2 free inputs were. The next step was for me to then look at the CAD drawings for the current table, and then look at a core that's been built up. Try and work out here where exactly I'm going to put the 2 additional sensors. I've labelled this with the 2 red arrows, but as you can see, the one further down, it's nearly on top of another sensor, and the one on up is very close to it. This could cause a problem because it's a very intricate core, and I cannot move the sensors that are there. But to be sure, I stopped the machine as a planned stoppage, put it in manual, and physically lifted with the core loader the core out of the pallet and into the broken core detection. In this picture, the 2 yellow arrows are pointing to what you can see from the outside of the oil leg. So it's a very, very small part that has to be sensed. The red arrows are showing the surrounding sensors that are currently being used. At this point it became very obvious. I can't use this sensor. Nothing else can go underneath to detect these. So I then had to go back to the sensor research. To the left is a SICK long range sensor. Now, I was familiar with this, so initially that was the one I wanted to use. I've used it before. They're easy programmed. It's just a high and low tolerance that you just turn a dial. But the problem I found during a bench test was the greater the distance, the beam can vary quite a lot in size. It was coming off at around 10 mil. If I put this on, it'd be reading a different part of the core as well as the oil leg. So even if the oil leg wasn't there, there's a great possibility the core will still get passed. The sensor here you can see to the right is the key ends distance based sensor. This was by far the superior sensor to be used here. There's a 5 meter range in this. The beam was around 2 mil. You can't change this, but obviously I wanted it to be as small as possible. There is a window function, which was perfect for this type of part of the core. You had a near and far tolerance you put in. I put these in at around 3 mil, plus or minus. This then meant, because there is parts of the core very close to this, but they're out of them tolerances, so if the oil leg wasn't there, it couldn't be seen. Now that I knew the sensor I wanted to use, I had to decide where I'm going to mount this. We've established it couldn't be mounted underneath at the table, and we're very cramped for the sizing around here. So I've depicted here in the 2 red rectangles parts of the machine which the sensor can be put and still reach to read the part of the oil leg. At that stage it was just simply make brackets. I did this quick and easy because that wasn't hard. It was just use 40 by 40 angle iron, and then I used channel. The reason why I didn't use the angle for both of them was the channel would be for the right hand sensor. Operators come in to clean the machine here, and I wanted to try and avoid it getting knocked because that is a possibility. After this then came the wiring. I needed 2 more 3-pin proxy cables. So in order to do this, the brackets were on. I knew where they had to go. I ran the cable in through flexible conduit and cable tied them to the parts in an area that it wouldn't affect the machine before it ran. I then wired the common 24 neutral. I then wired the 24 neutral to the commons. The switching wire, which is the one sending the signal, put it into the terminal rail for the switching wires and then up into the input at the top left corner here. The next step then was to power the sensors at the machine and then mount them. If I mounted the sensors onto the bracket before having power, I wouldn't be able to see the laser. And with the little room that I had, it was very important that I had power so I could then spot the part of the bracket I was going to drill and tap. This is the left hand side one you see is D3 at the bottom here, and inside the yellow circle, this is the laser pointing right onto the oil leg. And this is the same for the right hand side. At this stage we knew they worked. We did a couple of tests where the operator manually broke off the oil legs, and we checked to make sure it's very easy. It's orange and green. We're looking at the sensor to turn orange at the top as soon as the sensors are made, and green if they're not. The arrow line of the PLC programming here is just simple conditions. They're normally open. So this is all the sensors within this table. When all of them are made, they'll all be normally closed, and at the end you can see it looks like 2 closed brackets. This is a coil. This will then read true. Whenever this reads true, it will send a signal back saying yes, everything's here, it's okay to put the core into the die. So on the left hand side I've labelled it by a red rectangle. This is 6 months prior to me fitting the sensors. Overall you can see there's a huge amount of scrap. On the right here in the black rectangle is after I fed the sensors and got them programmed and implemented. This is showing a huge reduction in it. Overall, the project was a success. After 6 months, the scrap in a 6 month period went from being 70 down to 8. I was annoyed about the 8 because it happened from something I was trying to avoid. It was an operator went in and knocked him. Well, I don't know what happened, but that was the most likely thing. An operator knocked him. And then it was sort of back to me, right, well, how can we solve this? So if I was doing this again, I would ask the tool room department that we have, if I marked out the bracket accurately, where this sensor was going to go, would they be able to mill in a recess? By doing this, even just a 2 mil recess, it means it won't be liable for knocks. Or if it does get knocked, it can't move. So yeah, thanks very much. Any questions?
Very well done, Gareth. A very interesting project for somebody who knows nothing really about oil legs and things. And I guess you've saved there about £1,400
yes,
in terms of scrappage. And you've already done. What I was going to ask you was how much it was, but you kind of covered that in the last slide, and what you would do differently, which you've also covered. Can you see this being maybe used in other areas within?
Yeah, this was for the panther head. It's a cylinder head we make for Ford. And also that's on a line we would call Fata Free. It's a casting line. Just down from it is a very similar line called Fata 4. And the engineers asked me now to implement the exact same thing to that line, but for different parts of that core, because obviously it's a different core.
So brilliant. That's really good. Thank you.
I guess it's more a comment than a question. I mean, I do a lot of work with companies like actually Montepay and Bombardier and companies like that, and I know the drive for costs down and lean manufacturing and all the rest. So I'm sure they're delighted with that as a reduction of scrappage or whatever. And do you see, I mean, other sites potentially, there may be an application there as well?
Well, you see, as you put Montepay now Linamar Montepay, there are very different setups on the machines. You might have machines in Bulgaria, but there's very different setups. And I know our factory, because manufacturing costs here are naturally higher in Bulgaria. So the real thing that we need to be driving out, yes, the cost saving is huge. No matter what company it is, if you can save money, you're brilliant. But we really need to drive quality. Because that is exactly, that's what customers are looking at. Whenever you have a customer in visiting, they're looking straight away to scrapping. How much scrap are these guys making? Will we be getting scrap through the line to us after delivery? So they try and put us ahead of competition. Even our own, our own companies in different companies, we really have to make sure that our quality is on point. So by doing this, it shows that we can get better quality.
Yeah, I'd agree with that, Gareth. Well done. You're a great advertisement for Montepay.
Thank you.
So really interesting. And in terms of the bench testing, then, do you document that?
I'm a maintenance technician, so it was really left to me. It was like, we're happy enough. You've helped us get the solution, but now it's up to you, the engineers involved. It's up to you to follow on. You work away. I simply just rigged it into a simple 24 transformer onto the bench. Got a couple of bits of core. Measured where they would be in terms of where I wanted to place it, on the machine. And that was it. I just wrote down, on to the next one.
It is good. It's good to see that you're doing that, because obviously that's part of the whole research and if that particular sensor worked, and you obviously found out the first one didn't. And then the schematics, so then they're sent out to an external.
No, we update them ourselves.
Well, you update them yourselves.
Yeah, you do. Yeah, before doing that, you would have to do what we call now is a machine modification request, because you know yourself, it's very easy for me to be like, yep, I'll put this in, but then fault finding for someone else like me coming along behind. It causes a nightmare if you don't actually update the drawings.
Absolutely.
So it's very much driven now. Before you do anything, you have to do that request.
Great. Yeah. Thank you, and thanks to Stephen as well.
Thank you.
Okay, all the best.
Hi, my name is Lindsay.
And my name is Janet.
We are from the HND in Music course. We're both in our second year. I am a production pathway student and Janet is a performance pathway student. For this project that we're going to present to you today, it was for a module called Composing for Film and Television. So basically for this project, our aims...
Okay, our aims was to create an industry standard product using the knowledge that we've gained throughout the course. Through that, we'll have the aspirations to fully understand all the practical aspects and the tasks needed for composing the film. Also, it prepares us for the real music industry as well. and also to employ the vast variety of technology and the software to produce a very, very good high quality product. Okay.
So the overview, basically this project, we were actually given a choice of 4 different short films that we were allowed to choose whatever one we wanted, and basically it had no audio, no sound, no nothing, and it actually makes a big difference. I could watch any horror movie if it didn't have sound. So basically we were given all a choice, and we picked whatever film that we thought we could flourish at. I gave myself a challenge anyway for the one that I picked. And basically what it involved, so we had to compose an original score. So basically music background, however you wanted to use that, it needed a score. We had to actually then conduct a group of professional musicians. Then we had to help in the recording of those musicians. We had to individually record Foley, which is basically if in the film somebody drops something on the ground, we had to work out how we were going to record that and add it in. Sound design was used to add sort of a simulation of the environment that you're watching, so like background noise and anything that just adds to the visual experience. And then finally audio mixing, which is basically the final, whenever you've got all the audio captured, you have to mix it to be able to present it in a high quality way. So I'm just going to show you, this is our first clip.
That was my film. I chose the horror one. As you say, I'm on the performance side of the music, so my strengths would mainly be the music composition side rather than the Foley and sound design. What we used, we used the industry standard composition software called Sibelius. It's named after Finnish composer Jean Sibelius. It's highly used throughout the music world. Composers and songwriters would still use it. The college itself here, it would upgrade the software regularly to a more recent version, and sort of keeps the college on the same level for the music industry, which is great for the students and preparing them for the outside world. For the project itself, we had to show our creativity by generating the music score We used the choice of the 4 varied films, which gave us a chance to show off our initiative and our knowledge obtained throughout the course. We had to use 4 different instruments, which was part of the criteria. So we had brass, woodwind, strings, and percussion. So, and for the actual musicians, the professional session musicians that were coming in, we had one of them would have been a clarinet or saxophone. The brass player would have had a trumpet or flugelhorn. The string family was the cello, and then obviously percussion was the drum kit. Sibelius is like a template of like a manuscript, music manuscript paper that you may have used in school, where you had to manually put in all the notes, the minims, and using the musical stave. But Sibelius is obviously more versatile. We were able to watch the film and play the music at the same time. So Sibelius can play back the music using synthesized sounds, which is great because it gives you an idea and a perception of what your score is going to sound like when it's being played live. Once we had the music score and we were happy with it, then we had to add in dynamics, and that is basically creating the emotive responses through music. For example, some places on the film you would want it to be a bit quieter, whereas on the exciting bit where you would want it to be louder, and creating that sort of emotive response for the listener. Once we had all our fixes on the music score and we were happy with the score, then we printed off the 2 conductor scores, one for ourselves that we would be conducting and also for the tutor. And then from that score we were able to extract the different instrument parts and print them off to give them to the professional session musicians on the day. So basically, yes, we had to conduct our score with the professional session musicians, and tell you this was probably the most intense part of this project, but at the same time very enjoyable, but certainly taxing to the nerves.
Yeah. Our tutor actually craftily kept in, basically whenever we had finished our score, the point about prepare and produce a workable score is we had to make it, obviously as a production student I don't really use Sibelius that often, and would actually never be working with professional musicians up until now, and whenever we were doing proofreads between, sending it back and forth between our tutor, and then he was coming back, you need to fix this. Whenever we actually did the conducting on the day, there was a few, in everybody's score, there's always something that the musicians will actually ask, hold on, is that not supposed to be that, or why is that there? And our tutor actually left those slight queries in, because it actually made us realise that they're not just telling us that this is the way it's supposed to be, but for the sake of telling us. This is actually, it causes a problem for the musicians on the day. They're paid a lot of money to come in, they open your score, they play it straight away, and it's really fantastic to see, but it makes you realise that those little tiny things, something, a spacing of a note can affect the whole playing and how they read it, which was a really eye-opener to be able to be involved in that sort of scenario.
And it's certainly a learning curve as well, but we're going to see the second clip. This is Lindsay's clip.
Quite a strange film. And this was, I'm going to talk about now sort of the Foley sound design and recording aspect of the project. This is my strengths as a production student. So for all the recording of the musicians, the Foley sound design, we always use this industry standard project software of Pro Tools, which is a recording software for audio, and it's recognised throughout the industry as the most common used. For Foley, as I explained, it's any actions that happen in the film, and basically you have to record an audio that matches that makes it believable, and not everything has to be. For my video, there was a lot of different stuff going on, and I tried to get as much as I could, but things like, obviously at the start, the powder that comes out of the toothpaste, that's, if I didn't have that sound in, it would just, you would know it's missing, and you would find that it's not natural, which is what we're trying to do. We're trying to have an audience that is watching it and it makes sense to them, and also enhances the experience using the audio. For example, for that scene where there's powder coming out of the toothpaste, I recorded air freshener and dry shampoo at the same time and I was watching the movie while recording, so I was used various different things, because to get the right sound, you would never think of these things, but certain air fresheners didn't work, and then I found a dry shampoo aerosol that works, and whenever I was recording this, I'm watching the film to see the length of time that is actually on screen to make it more believable. So once you edit, you've captured all the Foley and sound design, which is using synthesized sounds, more electronic aspects, just to create like sort of a drone, or for example in Janet's piece there was like background like traffic and distant noise and things, and we used more electronic things for that that were found in Pro Tools. So whenever that was all recorded, you had to edit it and sync it exactly. So we had watching our movie, and then we had, maybe in my movie there's the girl turns on a light switch, so that's a tiny little click, and I had to sync it perfectly, because if it's out by even just a millisecond, you'll notice it and it doesn't work. So all for the length of the movie, you need to make sure everything's synced and keep watching it over again and see if anything sounds out of place or needs fixing. Then we also had to assist in the recording of that music ensemble. So the professional musicians came in, and we actually set up the studio the day before with microphones, chairs, microphone stands, the drum kit, and then on the day we actually helped by being recording engineer for somebody else. So every time somebody was going in and the musicians were recording their score, that person was conducting, and there was always somebody else in the control room that was helping with any technical difficulties, making sure that the recording level was appropriate. And then once all of this audio was finally finished, we basically have to mix and master all the audio to an industry standard. I was trying to think of how to describe this. Basically, if my analogy that I thought of was, if you're wanting to bake a cake, you put flour, eggs, sugar into a bowl. That's not a cake. You have to then mix it and actually make it a more presentable product, because whenever we have all this, there's a lot of tweaking and audio effects that we add onto it to make it a presentable piece for listeners, the level of volume and things like that. So then our academic outcomes from this project, it was a real big task, and with given the choice of 4 different movies at the start, we really had a lot of leeway and creativity to make some innovative choices in our project. You could look at say Janet's piece with the horror. You could completely change that and record comedic things and completely change the mood using the audio. So it was nice for us to have a choice to realise the visual in what way we wanted to. And also I personally have obtained a great professional level of competency doing this overall project, because you got to see everything involved and also dealing with professional musicians, which I felt it was a real honour and something that we had never experienced before, and I don't know if I'll ever will again, hopefully, because it was really enjoyable to see.
Yes, well, during this, the vast area of expertise that we've completed, we also helped each other, and as a class, with being mixed with production and performance, we did have a very good balanced support level for the class, and it was a good lot of team working. Obviously, my weaker skill would be the mixing and the mastering, whereas my strengths would be on the composing side of the Sibelius. So as a class, we were able to help each other in the different tasks. Also, we were able to self-analyze us critically to help us grow into industry knowledge and strengthen our confidence for preparing us within the music industry.
Another point that I just forgot to mention was the only reason that we can create such a high quality material is because of the industry standard products that we have here and all the facilities in the recording studio across there in the space. It's probably it's top of the range compared to, I know whenever I go out into the working world, I know I would struggle to get any work that has such like amazing facilities, and also like the software and things, and also our tutors really helped to make this project actually, like I definitely will be able to keep my movie for my portfolio whenever I go to try and find employment in other places. I'm proud of that because of the quality in it. So yeah, thank you for listening.
Yes.
Any questions?
Do you have any questions?
Very well done. Very, very interesting, well laid out presentation. And can I just say, I particularly like the fact that you took the time to explain the Sibelius and the Foley and the process and everything. I thought that was excellent for those of us who are not in that industry, but that made complete sense. And yes, I have written music on manuscript.
That's where I started off.
This question is out of complete curiosity. I mean, you're both in the music industry. Do you play instruments yourselves? If so, what?
Well, I played the flute during school, and obviously, quite a few years later, I've decided to take it up again, and I also sing.
Brilliant.
I sing and play the piano, but not in a public sense. But I can play the piano. But yeah, most of the production students will play an instrument, but there is the odd few that won't, and they are able to get through the course with flying colours because of their electronic understanding, and you don't have to play an instrument anymore to be able to do music, which I think is really fantastic. But it's using those software and things and synthesized instruments and that widens the course up to a lot of people as well,
and creates great
sound.
Yeah. Okay, brilliant. Thank you very much.
No problem.
Okay.
I guess again, maybe an observation more than a question. I mean, we ran a major creatives event in March past, and we had 12 companies in the morning and another 12 in the afternoon. But I think what was very evident was it was a real passion for their area that carried them through. But I guess the challenge, do you see the challenge of going into the industry at the end of this? Is it seems to be a very fragmented industry, and it's a very gig orientated industry. And do you think this portfolio of expertise that you've developed, do you think that'll be able to aid you in terms of getting project work, or do you see that you're going to go into it on a full-time basis, or what's the next step?
No, I totally agree with you that it's sort of a strange industry, but at the same time, whenever people come to me and say, oh, there's no jobs in music, and I'm like, well, things like this, composing for film and sound design, Game of Thrones, like all the stuff that's going on in this country, and there's more opportunities than what people realise, but also it is a lot to do with, I think, making connections and networking. For example, meeting those musicians, I actually sort of knew a guy that we had just met them on the day, but there was a guy I sort of recognised from different events and stuff, and I was able to actually strike up a conversation and introduce myself properly, and through that I think you have to hustle. You really do. And it's very much a passionate job for me anyway. Like, I know I was supposed to do maths at university back in the day whenever I was doing my A-levels, and every time I was picking music I just thought, no, I can't, I'm not good enough. But it's the passion that pushes you through, and you don't have to be the most academic knowledgeable person, but you could create a better outcome than somebody that does know all about it. It is sort of like, it's just your creativity that's sort of inexplainable, but definitely using this in my hopes to find employability after this. It's definitely something that other people won't have. They'll probably just have the normal recording portfolio, but this is something different that we were able to use the college facilities to, it was our first time really composing for visual, and it actually, works quite well, and it opens a lot of avenues now for me to, I would feel confident enough to go out and try and
next steps.
Yeah.
Very good. Personally for me, I think it was more of an achievement, this course, rather than a career move. I've been through 30 years in an office, and I just decided that it was time to do something different, and I have a passion for music, so that's why I chose it, and I've really thoroughly enjoyed every minute of it.
Excellent. Thank you.
Yeah, fair. I don't have any questions, but just like to congratulate you. You did a very good job, and for your first production, it was excellent. So well done.
Thank you.
Okay, folks, just want to say thanks very much for coming along today and sharing your various projects and presentations. I've done this in the past, and when I was a student myself many a long year ago, but it's a constant thing in the world of work where you have to work on projects, deliver presentations afterwards, show the whole process and show the outcomes at the end. And I think you all did fantastic. It's been a real learning experience for me, and I'm sure Heather as well, in terms of just the variety of projects that you students were undertaking. And I think they will be of real portfolio value, you know, if you're going to try and develop careers in these various spheres. You know, this is what employers want to hear about. They want to hear about real life experiences, because otherwise CVs and applications sometimes for employment can look very similar, and this is what stands out and makes a difference in terms of the project work that you've done and what you've achieved. So I just want to wish you all the best in your future endeavours, and thanks very much for your input today.
That's us. I'd like to thank everybody, in particular our guest judge, Deirdre from Business in the Community, for giving up her time to come in and give support to all of the students. I'd also like to thank Heather for taking the time to be with us today. I'd like to thank all of the lecturers, all of the students, the e-authoring team and everybody else who made it a success. Well done to all the students, and hopefully this will be a benefit to you going forward in your future career. Thank you.